Good morning, everyone. Welcome. Thank you for joining DataCon LA 2020. Welcome to the tutorials track, and soon we'll be listening to Introduction to Data Science session with Zia Khan. I am Andy Nakamura, your host, and our co-host today is the lovely Arti Anaswamy. We will be moderating the chat and Q&A for you during this session. Today, we have our guest, Zia Khan, and he will be talking about Introduction to Data Science. Thank you for joining this session. As an attendee, your microphone has been muted. Please be respectful to listening to each other when using the chat function, and refer to the Q&A section if you have any questions for Zia. Zia would prefer you to ask your question audibly, so if that is available to you, please do that in the chat, and Arti or I will unmute you and you can ask your question live. If for some reason that doesn't work for you, you can always ask your question on the chat and we will ask Zia then. Use the community section to interact with other attendees in the conference. This session is being recorded. I will introduce Zia. Zia Khan is the lead data scientist at the DevMasters. Zia is the DevMasters is a California-based science consulting and training company. Zia holds a master's degree in computer science with an MBA combined with over 20 years of professional work service. Zia's consulting portfolio includes healthcare companies, manufacturers, and startups. He is also the lead instructor for the Data Science Bootcamp offered by the DevMasters. Prior to joining the DevMasters, Zia worked with Bell Canada as a solutions specialist for data center and cloud computing technologies. Zia is passionate about driving information from data. Without further ado, I'll hand this over to Zia. Thank you for being here. If you have any questions, please reach out to me in the chat using your Wova app or desktop or laptop. On to you, Zia.
Thank you so much, Andy. Thank you for a great introduction. Much appreciated. Hello, everybody. Thank you very much for joining the session today. I hope you guys are all excited about this session. We are going to do it first time virtually. We have done this a few times in person at DataCon LA, but this is going to be our first time doing it virtually. So hopefully the experience is good, and DataCon LA people have done a great job at actually setting everything up. So fingers crossed, things will go well. As Andy was mentioning that I would like you to ask questions. If you have, you can ask Andy or Arti to actually unmute you so that you can ask the question. If you have any questions or if you get stuck, so my thought process is that I am actually going to run a session where you can code with me. So I am going to actually lead the coding and you guys can work with me. And what I will do is I will take a business problem and try to solve it. So that's the goal. And with that being said, if when we are doing the hands-on piece, I would like that if you are stuck so that you don't fall behind, if you ask the question, we will try to help you right there and then so that it does not, you don't fall behind because of that. I think that that we should be able to walk together and do this exercise. Before I get started, I was actually just curious to see how many of you have actually attended a DataCon session or a data science session before this, and I know that this is virtual, so show of hands probably would work. But if there is anybody who has never attended a session like this before, or is very, very new, like have never coded, I would like to kind of get an idea of that so that I kind of have an understanding of where the audience is. And while you guys are kind of making a comment on that or raising your hand, I'm actually going to start sharing my screen. Andy, can you guys see the screen?
Yes, we can see it. We can see the screen.
Okay, awesome. Perfect. So we are going to is primarily for people who are very new to data science. They're taking their first steps and they are trying to get in that field and want to get an understanding of what is data science, what is artificial intelligence, how are they related, what is big data a little bit, and then we will dive deep into that. We are going to, so the session time is from 10 o'clock to I think 3 o'clock. So what we are going to do is we are going to run a straight session for about, I believe we should be able to kind of get to the, or close to the end of it by 1 o'clock or in about 3 hours or so. So we will run it. And after that, I'll open it up for Q&A. So if anybody has any questions, I can help those. But for those people who have some other session that they want to attend, they'll be able to actually at that time maybe join the other session. So we are going to run a straight session. We will take a break or two in between so that everybody can go grab a coffee or something. And we will work through that session in one stretch. Earlier, we were thinking that we will do a lunch break in between, but I think if you guys are okay, we'll push the lunch break a little bit further down, and we will try to do a straight session. All right. So the learning objectives for today are that I am going to actually, and I'll explain the business case a little bit, but it's primarily the business case is that you're going to help a bank figure out that if they should extend a loan to this customer or not. So what we mean when you read this first bullet point, which is the probability of a customer loan default, what that means is that if the probability of a customer to default on the loan is very high, you really don't want to give them the loan as a bank. If the probability is low, you want to give them the loan. So we are going to actually calculate that probability, and then based on that, we will decide should we or should, as a bank, should the bank give a loan out to the customer or not. Before we dive into that use case, we will actually talk about a couple of different techniques in machine learning, supervised versus unsupervised. Then we will do the model. And then between those, I will talk a little bit about some basic we are walking through. Inside is doing a lot of PowerPoints initially. I'm going to actually, as we walk through the exercise, I'm going to explain that when we are doing it. So that agenda, and again, in between maybe 10 minutes. Would that be okay, Andy? If we
Yes, but I believe your video is cutting in and out. Are you there, Sia? I think we lost Zia for a little bit. Hang on, everybody. In the meantime, everyone, if you could post in chat if this is your first experience with Python or not. We're having a few difficulties. We just lost our speaker there. See if Artie can find him again. Again, if you could mention in the chat what your experience level is, if this is your first time with DataCon, or you have seen this presentation or have experience with data science before. Oh, I see we have him back. Are you there, Zia? You're on mute. Are you there? Did we lose him again, Artie? Or is it my connection?
No, I'm not seeing him online.
Oh, okay.
And I know we got a couple of questions on the chat, so I just wanted to clarify. We'll be using a data set that I've posted the link to on the chat and on one of the questions that was asked on the Q&A. So if you guys want to go ahead and download that data set and let us know if you have any trouble downloading it. In terms of installing any technologies, we're going to be using the Google Colab, which I believe comes installed with the software you'll need. So you should just be able to participate in the hands-on exercises directly through the Google Colab. And once Zia has concluded his presentation, which will go for about 30 to 40 minutes, depending on questions, we will then open it up for the Google Colab for everyone to go in and participate in that. So let us know if you have any questions in the meanwhile.
There is a question. It says Zoom doesn't seem to have a chat box feature enabled. And I think Artie already said that. If you go into your WOVA app, it's in the chat there. Also, if you have problems or you can't see or something, please raise it up in the chat in the WOVA app.
In terms of your audio participation, I believe you should be able to use the mute unmute buttons to speak up if you have any questions. But yeah, the chat is basically using the Whova app on the right side.
I'm just taking a couple of notes from the chat, and it looks like we have more people that are beginners or first time at DataCon LA. Hey, Artie, there's a question on the chat. Can you link the Google Colab? I think it's just colab.google.com. But Artie will post it in the chat.
We don't have the Google Colab link at this time. I think Zia was looking to conclude his presentation and then share it. So we'll have it at that time. But the data set you should be able to download. Let us know if you don't see the data set link.
Feels like we're going to do a dog and pony show. And here's DataCon. Maybe Artie, you can try to reach him through the phone and see if he can do the whole thing through cell phone. Okay, we're trying to continue to reach out to him. We're reaching out to the organizers now, seeing what they can come up with. This is the wonders of technology going through remote presentations like this. So please be patient with us. Looks like we're getting something. Isaiah, are you there? You're on mute. Oh.
Let's try it now. Can you guys hear me?
Yes.
Okay, my apologies, everybody. I am so sorry. I was just talking about that the internet might be a little choppy while I'm here. And at that very moment, it just said that I am not going to work with you anymore. So hopefully, Andy, you can still hear me?
Yes, you're good
Yeah,
to
we
go.
can hear you.
Oh, okay, okay. I am a little paranoid now, but so I'll check with you after every few minutes that that you guys can still hear me. But let me go back to the presentation.
While you were out, we asked the question who attended the first time, and it looks like we have more attendees that are either attending first time at DataCon and a little bit of experience with data science than those who have attended or have been in data science, just to let you know.
Nice, nice. All right, so that's good that we have a really good group, a little bit diverse, which is nice. All right, so I was just talking about the agenda a little bit. So that's what we are going to talk about. And then after that,
We're not hearing you, Zia. Artie, are you there? Or is it my connection?
No, I can't hear him either.
Oh, okay. Well,
I was going to say thanks everyone for being patient. We're going to try something different here. I think we might just see if he's able to call in via video, and then maybe we're able to share the presentation. Let's see what works. I think we're going to have to get creative. Hey, Zia, you're back.
Yes. Okay, let's see how that works. So I have actually, I'm now tethering with my phone. Hopefully this is a little bit better than the Wi-Fi
perfect.
here.
Yeah, Zia, if you
so
want to share the presentation with us, we can also have it as a backup just in case.
I can certainly do that. Okay, so let me get to the presentation, and hopefully it gives us this time maybe 10 minutes for me to speak and before it goes out. Okay, and then I'll share the presentation, Aarti, for sure. All right, so this is where we are. And again, guys, I'm very sorry. I'm not sure if I was when I was speaking, you guys heard me or not, but I had to travel outside of US for some personal reasons. And that's why this challenge happened, and it was very sudden. So I had like no other option. So I like to start off with this. And the reason I like to do that is because I want to put everything in perspective. I want to showcase that why companies and everybody is talking about data science, and what's the importance, what's the reasoning. So if we look at all the larger enterprises that are around us, we will see that all these companies have a lot of data. So we can see that at Google, this is a 2020 slide, which shows us that how much or what happens in 1 minute on the internet. So we can see that for Google, there are 4.1 million search queries in every minute. If we look at maybe Netflix, we see that there are about 764,000 hours of Netflix TV watched every minute. So that is a lot of data. If you look on the right-hand side, you will see that there are about 200,000 people who tweet every minute on the internet. Now, if you are a company, for example, if you are Coca-Cola or Pepsi or Johnson & Johnson or anybody who's dealing with consumers, and if you want to find out what people are saying about your brand, so if McDonald's is interested in finding out that what people are talking about all over the world about McDonald's, what can they do? They can actually go to Twitter and start kind of looking at the tweets that are coming in. But if there are 194,000 people that are tweeting every minute, it is very difficult for McDonald's to have that many people actually reviewing the tweets and finding out what people are saying. At that time is when companies can actually use computers to help them out, because computers are fast. They can process a lot of data at a very fast speed, but computers have to be trained. And how you train those computers is what is basically machine learning. So you make the machine learn so that it can actually do some basic work for you, and you can spend more time on doing which is more important, and you don't have to get into doing mundane kind of work. So computers can do that, and they can do it consistently at a very fast speed. If we go to the other side of the same screen and we see that there are about $1.1 million that we spend as a human race on shopping every day. And, oh, sorry, not every day, every minute. So $1.1 million spent every minute. And that's a lot of money that's being spent. And that's a lot of data that is being generated. And by Amazon, if I remember the stats correctly, I believe they say that there's 17% of their sales comes from a recommendation system or a recommender system. And a recommender system is nothing, but it looks at the trends of what a user has bought previously and what could be something new that he can buy, so they can recommend a movie. Similar for Netflix, if you watch a movie, they will recommend you another movie based on what you have watched. So all these techniques or technologies that are there, they are actually kind of looking at the data, which we have lots of. So technically, data science is not something new. Companies have been doing this for a very long time and trying to do this also for a very long time. What we have now, or why there is such a big hype about it, is because we have lots of data. Storing data is inexpensive. So cloud storage or object-oriented storage has actually made it economical for us to store data. So now even smaller companies are able to store a lot of data. And the computers are fast, and we have a very reliable internet. And all of this put together actually makes data science or work better. So all of this actually makes the environment right for us to us meaning companies, to actually get creative and start using that data to actually understand their customer a little bit better. And then once they understand the customer a little bit better, they can help the customer find the right thing. The one thing that happens on the internet, and you guys can try that, is that if you go to Google search and just search data science courses, you will find so much information, so many courses. Which one is the right one for you? If computer can help you find that would be great. And how can a computer help you find out or find that right course? Is by understanding your needs or understanding your requirements. So if looking at your data and looking at your history, if it can actually filter out some of the courses that, okay, you have a major in math, you are good in computer science, so this might be the right field for you. So here is the course that you should look at. So this is how data can help people, and by helping the company understand the customers better and then giving the right kind of suggestions or presenting the right kind of solutions to the customer. Now, this is what the companies do not want. They do not want to be data rich, but information or insight. We have a lot of data, but we don't know what to do with it. So that is where companies do not want to be. And that's why companies are looking for people who can look at data, analyze data, get some insight and information, and help the company understand the customers so that they can present the right product to the user at the right time, or present the right course to the user, or the right service to the user, or the right technology to the user at the right time. So hence the demand that we see for data analysts, data scientists, data engineers. All of that is driven by the amount of data that we have, fast computers, a very reliable internet, and inexpensive storage helps companies analyze that. And that's why they're looking for people who can do that. So what kind of skill set does or should a data scientist have, or does a data scientist need? So of course, you do need some computer programming skills, some kind of communication skills. You do need background in math and statistics. And not the last, it is a very important aspect also, is domain knowledge. So understanding the industry, understanding what is happening in that business field. So if you are going in a real estate market, you need to understand the real estate market a little bit. If you're going in healthcare, you need to understand healthcare a little bit. If you're going into banking and finance, you need to understand banking and finance a little bit. So all of these put together is what a data science. So it's a multidisciplinary field, data science, where you need to have a knowledge of a few things to actually make a whole of that. All right, so now let's talk a little bit about, and I mentioned this a couple of times in my like earlier, that machine learning. So we make the machine learn, and in machine learning, primarily there are two types of techniques that we see. We see a technique where we make the machine learn from historical data, and I'll get into that because I'm going to do an example of supervised learning. So you have historical data. Now, historical data could be your customers that are present. So Netflix, their existing subscribers, that's your historic data. So you make the machine actually learn from historic data, and then you give it the data that comes in today, so the new data, and you try to see that if the machine can actually tell you that based on the historic data, looking at that, can I tell you what this next, what is going to be tomorrow? So taking an example of Starbucks. Starbucks sells 100,000 cups of coffee every day. Now they're selling 100,000, and all of a sudden they sell 200,000 one day. And yes, you want to find out why did we go from 100 to 200, and that's all historical data, that's in the past. So that portion of in the past is actually data analytics. So you're looking at data and you're trying to figure out what happened and why did that happen. So that those two pieces, what and why, is history, is in the past. So that's data analytics. Now you go to the next step, which is how much is Starbucks going to sell tomorrow? That is predictive analytics. So now you are trying to predict what is going to happen tomorrow. Are they going to sell 200 again, 200,000 again, or are they going to go back to 100,000? And based on that, Starbucks needs to have the right amount of people in their stores so that they can serve the customers. So this kind of information can come in handy for many different ways, but this is what predictive analytics is. So you're trying to figure out what's going to happen next. And you give your machine, so in supervised learning, you give your machine historic data and it learns on that and then predicts on that. But the major difference between supervised and unsupervised learning is that in supervised learning, you already know what happened last time. So how many customers came last month? You know that output. In unsupervised learning, you do not know that. So you have no idea if the customer in the historic data, did they buy from you or did they not? Did they just come in the store and just went away, or did they actually buy something from you? So in unsupervised learning, we do not have the information that if the action was taken or not. So in data science terms, we say that we do not have the target variable. So in this portion of unsupervised learning, we do not have the target variable. Sorry. And in supervised learning, we know the target variable, and when we know the target variable, we basically are doing supervised learning. Now, supervised learning within itself is divided into two different categories. One is called regression-based or estimation kind of learning or models. The other one is classification. The difference is that when we are actually predicting a real number, which is like what's the dollar amount of sales, how many liters of gas do we need in the car, or what's the sales forecast, or what's the price of a house or a product or something, those are regression-based problems. When we are trying to classify things into groups, so is it going to fall in group 1 or is it going to fall in group 2? Whichever group is going to go to, that is a classification problem, because we are trying to group things together. So they're kind of, this is in category 1 or class 1, this is in class 2, this is class 3. So if we have different classes, then those kind of problems are called classification problems. So this is very high level, tells you a little bit of an idea of what machine learning is. And if you have a problem, you get an idea like, okay, this is a supervised type of learning, and I'm going to do classification on that. So that's a little bit about machine learning. Now, we hear these terms all the time: artificial intelligence, machine learning, neural networks, deep learning. What's the relationship? How are they put together? How are they kind of related to each other? So the overarching field that you see in this blue circle here is artificial intelligence. So artificial intelligence is basically making machines intelligent. Now, for artificial intelligence, the technique that's used mostly is machine learning. And the artificial intelligence includes other things like robotics and stuff like that. So machine learning is a subset of artificial intelligence. You use this technique to make the machine learn. So we see this bigger kind of a little bit darker blue shade here for machine learning. Now, within machine learning, there are many different techniques that we can use. I mentioned a couple of them. I mentioned the regression, I mentioned classification, I mentioned unsupervised learning. They're all types of machine learning. One of the type of machine learning where we actually just focus on one technique is called neural networks. And neural networks is a technique in which we have a feedback loop, so they learn a little bit from themselves each iteration. So that's a neural network technique that we use. So it is actually a part or a subset of machine learning. And then within neural networks, we could have layers. And if it's a one-layer network, it's a neural network. When we have multiple layers, so more than 2 layers, then it's a deep neural network. And that's also called deep learning. So deep learning is actually a subset of neural networks, which is a subset of machine learning, which is a subset of artificial intelligence. So or at least this is what we believe, that this is how their hierarchy is set. And you can actually kind of see that, okay, if I'm doing machine learning, there could be many other techniques, and neural network is one of the techniques. Now, we hear big data. So I have this other circle on the side, which is big data. Now, big data is actually lots of data. It could be different types of data. It could be videos, it could be audio, it could be text, it could be tabular data, whatever type of data. But we have a lot of data that cannot be processed on one machine. So we need many computers to actually work on that. That's like big data. Now, if you have big data, you still have to do machine learning on it. You still have to do neural networks. Whatever is the right technique for you, you still have to do that portion of it. So by just having big data, or by just having a lot of data, it doesn't mean that you just have machine learning, or you are actually doing something with it. You still have to do all these processes on big data to actually make information or get insight from that data. And data science is actually the technique which uses all these technologies underneath to get insight or information from data. So it's the science of data. So we run different types of experiments, we try different types of techniques. All of that science of actually driving information from data is actually called data science. So from our perspective, this is how these three, we hear a lot of these: AI, big data, data science. So this is how we believe that these are interrelated between each other, and one kind of leads to the other. But a little bit of an overview of what AI and big data and data science is. All these companies that we see, the big brand names that we use on a daily basis, they all use data science. They all use all of these. They all have big data. They all have. They all use either machine learning or deep learning or some kind of learning where the machine can learn some kind of machine learning, and then they try to do some data analytics, and they try to do some predictive analytics on that. it's for any company that is now actually in the market, they have to compete with larger organizations, and that's why we see that smaller companies are now getting more and more into data science, because for them to compete with them, they have to have these systems in place to drive information from the data so that they can compete. And that's why we see, again, just going back to the fact that the reason that we are seeing this hype is because of that. All right, Andy, Arti, are you guys still able to hear me?
Yes.
Yes, you're still with us.
Good.
Okay, good stuff, good stuff. 10 minutes this time. You're making some progress.
Oh, Zia, not sure if, I think you might be okay, like stopping your video just in case that helps.
Oh yeah, that's a good idea. Yeah, if it breaks down next time, I'll try that without the
Sounds
video. Okay, great. So the next thing that I just wanted to kind of touch on a little bit is one of the techniques that companies use. So when we are doing machine learning, when we are doing deep learning, when we are doing AI has a larger subset, so I'm not going to say AI, but when we are doing machine learning or regression-based learning or classification-based learning or deep learning, there are many different methodologies that can be used for your data. One of the methodologies is CRISP-DM. It stands for Cross-Industry Standard Process for Data Mining. It was developed, I believe, in 1990s, and it's one of the methodologies that a lot of companies use. Companies have kind of tweaked, so it's a methodology and not a process. So that's the first thing that we need to kind of understand, that it's a methodology, meaning we do not have to do all the steps, and we can tweak the steps a little bit because it's a methodology, and it's not a step-by-step process. So a lot of companies have made tweaks to this methodology and come up with their own process or their own system or their own technique to do that. Same DevMasters. We at the DevMasters, we use a technique, but it's a kind of a tweak to this model. We follow this model, but we have made a few changes to fit our business processes, and that technique is what we use for our problem, like for our solutions. The reason a lot of companies like it is because it starts with business understanding. So if you are solving or if you're doing a data science problem, and if you do not know how you are going to help your business, I'm not sure that if the company would be interested in too much, because the company's goal is basically business. Whatever the underlying business you are doing, their number one goal is to help the company grow, have more business. If it's a service, if it's a nonprofit, you want to help more people, and that's your business objective. So you have to tie whatever you are doing to a business goal, to a business objective, and for that, knowing or understanding what you are doing to help the business is key. So that's one of the reasons I really like this methodology, is because it starts with a business in mind. And then after that, there are multiple steps. We actually look at the data, we understand the data. Today, when we do the hands-on piece, we will understand the data a little bit. And then there is data prep. So we understand the data, we prepare the data so that it can be used by the model. Then we have the model technique. Then we evaluate the modeling technique and the business, both of them. And then we deploy. So if we are happy, then we deploy. If we are not happy, we go back and do some more business understanding, data understanding, preparation, and we tweak the model and then come back and then check and come back. And so this is an iterative process. And we go through these cycles. And that's where the experimental piece of data science also comes in, because some of these are being just run as experiments. And then when the experiment is successful, you test it. And when it's mature enough, then you give it to the production team to actually deploy. So this is the technique, this is the methodology that a lot of companies use for data science, or a version of that. All right. So now we are going to start moving towards our project today. So so let me first set up the project so that everybody is kind of, and again, I was talking about business objective. So I'm going to actually underlie or kind of explain the business objective to understand that why we are doing it. So the example here is that it's a bank data set. And the goal is that we are going to make a model, or we are going to train an algorithm that will help us find the bank, that will help the bank find out if the bank should actually extend this loan to the customer, if they should give the customer the loan, or if they should not. And we will do that by actually trying to find out the probability of the customer repaying the loan back to us. So would the customer be able to repay the loan back to the bank? And if they can pay back the loan, the bank would be happy, because that's how banks make money, is by charging interest on that loan that they give. So they want to make sure that the customer can pay back the loan. All right, so this is, I talked about CrispDM, and this is kind of very similar to CrispDM. So we have a business objective. I did talk about the business objective a little bit, and that the bank wants to build a model whereby it can find out if the customer is going to repay the loan, and if the probability of repaying the loan is high, they would give the loan. If not, they would not. So that's the business objective. The first step is data acquisition. So yes, we have a business goal now. What and where is the data? How do I find the data? So anybody, any thoughts on how we can find the data? Where can we find the data? So you work for a bank, Wells Fargo. You work for Wells Fargo. The Wells Fargo team comes to you and says, okay, we want you to build a model that will tell us that when a customer comes to our website and he enters his name and social security number and his date of birth, we want to tell him that, okay, we'll give you a $20,000 loan or not. Any ideas, anybody, on where would you find the data? You can put it in the chat, and Andy and Artie could kind of see that.
Zia, we have a suggestion that from Perry Rivera, that we could check the customer payment history.
Very good. Excellent. So thank you. So you are on the right track. So what you do is, when your manager or when your director or your management comes to you and says, and build a model, the first thing that you do is you actually go to your database team and you say, okay, guys, I've been asked to actually build a model like this. I need some data. Do you have some historic data for the customers that we have? Can we look at the customer? Can I get that data so that I can actually build something based on that historic data for the customers? So you go to your database team. Database team says that, yes, we have data for the last few years. Here is a data for 5 years for you. You can take this 5 years data and have fun. So you take that data. Now you have acquired the data. You have the data. Now, how do you get the data? Is it a database connection? Are they going to give you a CSV file? Are they going to give you an Excel? Is it on big data on Hadoop, or is it on Spark? That's all details in acquiring the data. But what you really need is the data. So once you get the data, and you can get data from any of these sources. Once you get the data, then the next step is you look at that data. So you look at the data, what do you have? And once you get an idea of what you have, you prepare the data so that it can be fed to a model. So now you get to the modeling technique. So you acquire the data, you analyze the data, you prepare the data, and then you give the data to the model. And the model actually learns, and then you test the model, and you find out that, okay, my model is doing fairly decent. My model can predict for new customers 60% of the times that the data, 60% of the times correctly, that if the customer is going to pay back the loan or not. So we basically are able to build a model that has an accuracy of about 60%. Now, you are excited, you are happy, you build a model, you go back to your manager and say, I have built a model that actually is able to give me 60% accuracy. And I can tell you with 60% surety that if the customer is going to pay back the loan or not. Now, if when you go back to your manager is going to be like, okay, 60%, maybe not. We need something which is a little bit higher. Maybe I need an accuracy of 80% or 90%, whatever your company's threshold is. And that threshold is actually dependent on the industry. If you go to marketing people, salespeople, 60% accuracy might be okay. If you go to banking, maybe they need 80%. If you go to healthcare, they need 99.9% because they're dealing with lives. So it depends on the industry that what is okay and what is not okay. But you evaluate that, and if it's not okay, where do you go? You go back to the data acquisition phase. And you go back to your IT team or your database team and say, okay, thank you very much, guys. You gave me 5 years of data. I built a model. It's not good enough. Do you have more? And then you say, and then they will say, okay, yeah, sorry, we gave you 5 years, but we have like this 20 years of data. So then they give you all 20 years. And you take that data, you go through the whole same process and you evaluate again. Now, earlier you were 60%, with 20%, you come up to 80%. So with 20 years of data, now you are at 80% accuracy. You go back to your manager and say, okay, 80%, is that good enough? And your manager says, I think I need a little bit more better. 80 is okay, but it's not good. I need it to be at 90%. Now you're like, okay, what do I do now? So my algorithm is at 80%. I need to improve it. What do I do now? So you go back to data acquisition. Now you go back to your database team and say, okay, guys, you gave me 20 years. Thank you very much. Do you have some more? And they would be like, no, we gave you everything we had. We had 20 years of data. We gave you the 20 years of data, and we don't have anything else. What do you do now? Any ideas? So at that point, when you have exhausted the data that is within your organization, then you reach outside the organization. So you will go to the credit bureau and say, okay, can I get some kind of a history for this person for travel? Where does he travel? You can actually go to maybe some other site and find out a little bit about where he lives. What kind of information do we have about that region? Does he live in a city that has a very high population of people who are very highly educated? So those kind of external data that you get from you maybe look at his Twitter page and see what kind of things he likes or how many people follow him, or you can actually look at the Facebook, whatever is public. You can see that information and build something based or include that data in your data with the goal that now you need to do the whole process again. So you will prep and analyze the data, build a model, and then you actually evaluate the model to find out if you hit that magic number what the company was looking for, which was 90%. So this is how an iterative process in data science works. So you go within your organization. When you exhaust that data, then you go outside the organization to find out more data so that you can actually help build a model. Once you get there, there is also process within actually that, okay, different modeling techniques. So I want to use neural networks. I want to use deep neural networks. So you actually can change the techniques to actually improve the results also. So that's another step that you can do. So once you have exhausted all the data and you have everything, and you still want to improve, then you look at the modeling techniques and see if there's a better modeling technique that's suited for your algorithm, for your business problem, so that you can use that algorithm to actually help you out. But this is what an iterative process within the data science cycle is what we use to actually solve a problem. All right, so we are going to do a little bit of this today as we move along. So now I think we are going to, so this one says CoCalc, but I am actually going to use a different, guys, you can still hear me, right?
Yes.
We can still hear you.
Okay, perfect. Okay, so what I'm going to use is not Facebook. We are going to search in your Google browser. You can search Google Collaboratory. Collaboratory. So once you search Google Collaboratory, that's the tool that I'm going to get or I'm going to use today. You can click on this Google Collaboratory, and when you click on Google Collaboratory, or Colab they call Google Colab, it will open up a page, and yours might only show welcome to Collaboratory, and all you have to do is click on this button, New Notebook. This new notebook will, once you click on this new notebook, it will open up a notebook for you. So when I just clicked on that, and just give it a second. Of course, the internet is slow. It will open up something like this. And this is the name of that. So you can click on this, take the untitled out, and you can say data science, and then leave the .ipynb as is. IPYNB stands for IPython notebook. So this is kind of an IPython notebook, and we are going to use that notebook to do that. So this is going to be your coding cell, and you will see a browser like that. Once you get to this page, this is where we are going to code. So we will start coding from here. The next step would be to actually click on this browse or this files icon here. And once you click on the files icon and you have a connection to the Chrome, it will allow you to upload the data set. So you click this upload button and it will allow you to upload the data set. And then you find the data set that you have. Yeah, so machine learning loan default data set. You click on that data set, click open, and it will allow you to, and it will give you a reminder that all files will be deleted when this runtime is recycled. So when we get out of this runtime, everything is going to go away. So you just click OK, and that's fine, because we can download this notebook on our local computer, and I'll show you in a few minutes. But these are the next steps that we will do. So, so Andy and Artie, I think this is where I would like to take maybe a 10-minute break so that people can actually upload the data. And also people can kind of maybe grab a coffee or drink or something. And we will give people a little bit of time. For those people who run into any challenges, who are unable to actually upload the data or that, they are welcome to actually, please feel free to kind of put it on the chat, and then Andy or Artie would actually unmute you, and I can help you get to this place. But this is where we are going to start from. So please upload the data, the machine learning loan default data, and just get to this point so that we can get started. Does that is that okay, Artie?
Yeah, thank you, Zia. And for everyone's benefit, if you go over to your Whova apps and look at the Q&A tab, I posted a new question and put in the links to both the Colab, which you would set up your own notebooks, and to the dataset link, which is on a Google folder. So please let us know via chat if you don't see those links or if you have trouble accessing. And we will plan to be back at 11:10. So if you need a coffee break, go ahead. Or if you have any questions, we'll be on the chat.
Thank you, Artie.
Asia, are you there? Or you must have taken a break.
Sure. Hey, everyone. So I think we saw a couple of notes, a couple of chat items to repeat the steps. So let's see if we can share our screen and show you what to do. So Andy, let me know if everyone can see my screen.
Not yet. Yes.
How about now? Okay. All right. So I'm on the Google Colab link, and over here, you should, if this is not sort of pulled out for you, you might see a table of contents over on the left, and then a find and replace, the code snippets, and then the final item is files. So in the files section, if you have not added your data set yet, what you should see is just the sample data that has some of these data sets preloaded. What you're looking to do is add the data set that we shared on the Google folder link. So if you go back to DataCon LA, or the Huba app rather, the session Q&A, and if you look at the first question, I have pinned it to the top, so links to resources. You should have both the Colab link and the dataset link. So if you go here and download the dataset and have it on your desktop, what you want to do is come back to your Colab and click on this first icon here that says upload to session storage. So once you click on it, it will let you find the dataset on your downloads link. Click it, click open, and it should add it to this section here. So let's try that again. So here. You want to click on this, download. And then go over to your Colab. Click on the fourth tab from the left. So this folder icon here, click on Files, Machine Learning Dataset, Open. Andy, are you seeing any other questions on the chat?
Someone's saying, I think via Hav said it's not getting downloaded, but I'm able to download it. Maybe you check your Google. Are there other people having the same issue, or is it just Hav?
Sorry, guys. Yeah, I was. What challenge was that?
Someone posted in the chat that they're not able to get to the data set, but
oh, data set. Okay.
I don't see anyone else posting they have that issue.
Okay.
And they were
And
asking.
yeah, sorry, Zia, I'll transfer the screen over to you. We were showing everyone how to add the data set. There were a couple of questions on repeating the steps, so I'll stop sharing.
Yeah, please do. No, Arti, that was okay. You can actually definitely do that. Yeah, let's see. Anybody else having the challenge of not being able to get to the data set? Seems like that everybody else is. You guys can hear me, right?
Yes, we can hear you.
We can hear you.
Okay, good.
Yeah, you just have to share.
Zia, a few other people responded and said they weren't having an issue. So Vaibhav, we'll see if we can maybe email it to you. Let's see how we can accomplish that. But go ahead, Zia.
Yeah. Okay. So I know that there are a couple of people, or maybe one person, that's having some challenge with the data set, and we will get that sorted out. No worries. We'll move a little bit slow so that we keep that in there. Give you a couple of minutes to catch up. Anybody else who is not able to upload the data set like this? And I know that this will be empty, but that's okay. Just the data set is there. If anybody else is having any challenge, please let us know. I am actually going to now switch away from this notebook to a different notebook that has a few things pre-populated, but there's no. I'm not going to do any step that you haven't done that. So we will do one step at a time as we move along. But the first prereq is that we have this data set here. So I'll give people 30 seconds to respond in the chat, and we'll see how that goes. And I will switch to the other notebook. Guys, can you see the screen?
Yes.
Okay, great. So no one else with any challenges, right?
There's a few, but we're working them out.
Okay, okay, great. So I will wait another minute or so. For those people who have everything here, if you click on this left folder icon, you can actually make it a full screen. And if you want to see the file again, you can just click on that. So it actually kind of splits the screen. So I am actually going to click so that it becomes a full screen, and I can talk about that a little bit more. All right. So we are going to get get started. And again, if you guys are a little bit behind, no worries. I'm going to talk a little bit about Python and a little bit about pandas while you guys actually get the data set uploaded. So the language. Again, just to kind of recap in a minute, the problem that we are solving is that we are going to actually help a bank figure out who should they give loan to and who should they not give loan to. So who is a good customer for them and who is not. So that's our business objective. That's what we want to solve. So I'm going to talk about the technique or within machine learning what we are going to do it. But before we get to machine learning, we have to pick a language. We have to pick a computer language that the computer can understand to actually solve the problem. I am going to use Python for this. You can use R, you can use C, you can use any other language. The reason Python is a little bit more popular or getting the more traction these days is because of a very big community that is actually supporting Python for data science. They have built a lot of great, we call them libraries in Python, that help make process or make coding simple for you. So you can do a lot of work with the few lines of code. And one of the libraries within Python is pandas that I'm going to use. Again, the edge or the benefit that Python gives you is that because it has a very big community that contributes to Python, I actually, or a lot of companies or a lot of people use Python because it makes coding easier and faster. And for companies, when you can code something or build an application faster, it's shorter time to production, which is a big thing because they want to get, if something can help, they want to get through it as fast as possible. So we're going to use Python for this. And within Python, we are going to heavily rely on this library called pandas. So we are going to start building this with pandas. Now, in Google Colab, your first cell would look something like this. Let me move this up. So your cell looks like this. Now, within this cell, you could have a code cell or a text cell. When you click on text, you see it's a text cell, and I can write pandas here. And once I enter pandas or I do shift and run, you can see the pandas here. So how you run a cell is by clicking this start button, or the other option is you can hold the shift key down and press return or enter, whatever you have. So a code cell would be, so this is Python code. I'm just going to write print hello data scientist. And then once I've written the code, because this is the code cell, I will do shift and enter, and it will actually execute the command print, and it will actually write the hello data scientist here. When it's a text cell, the text cell allows us to take notes. So the cell that you see here, where I've put these notes in, this is a text cell. And the text cell actually takes HTML tags. So you can actually bold and center and all those kind of nice things you can do. And that's one of the reasons that a lot of people like notebooks, is because you can make comments, you can actually build graphs, and we're going to do a couple of them also. So we are going to use pandas to build this, and I've written this in the text field. Now, how does the pandas library help? So how pandas library helps is by creating something which is like a spreadsheet. So pandas has this concept of data frames, and a data frame is nothing but it's just like a spreadsheet. So it's a two-dimensional spreadsheet. You have rows, you have columns, and it actually takes the data and puts it into a tabular form. It's just like table.
We seem to have lost Zia again. Hang on, everyone. maybe RT, you can see if anyone else having issues still. Maybe re-show the, oh, there he comes. Hi, Zia.
Oh, did I lose you guys again?
Yeah, you lost us for a little bit.
Okay. Where was I when I dropped off?
You had the pandas page up.
The pandas
Pandas
page.
page up?
Yeah.
Okay.
And Zia, we are having a couple of attendees who are having trouble. They're seeing some sort of error when they add the data set. So once you're done with the pandas overview, maybe we can take a pause and take a look at those. Thank you.
Sure. So let me, so I'm actually, I did try make a hotspot. I am actually going to keep my phone by the window there. So bear with me for one quick second, guys. Let me just try and see if that helps. All right. So hopefully this connection is a little bit better there. Okay, let me share my screen again. All right, so let's there's so many things that we can talk about pandas. So I'm going to actually kind of give you the highlight of it. So pandas helps you read data. Panda helps you read data and put it into a tabular format, and then do SQL-like operations on pandas. You can actually do regular expressions with pandas. You can do a lot of things, and we'll do some of them so that it will give you an idea of what and how like powerful pandas is. But it's an amazing package. So the bigger community that helps Python and pandas, yeah, hats off to them. They have built a really nice library that is very, very helpful. So we are going to use pandas library to actually read the data that I sent. But before we go there, let's find out what kind of challenge people are having, RT, and we'll try to see if we can get that solved.
Sure. So some of the issues we're seeing are when the users tried to attach the file, it says error could not fetch machine learning loan default data set from backend. Perry shared a suggestion that if the users try to save it as a new file and upload that second file, that might work.
That's right. So it's a CSV file, guys. So when you download it, you can actually save it. Try saving it without the spaces. Maybe that will help. So change the name and just make it very simple. Maybe just say dataset, one word, so that it has no space, .csv. For people who are using Windows, let's not open it up in Excel. Because if you open it up in Excel, sometimes Excel changes the format from CSV to Excel, and that conversion can actually sometimes create. So download it, save it on your desktop, and try to upload it. And if that doesn't work, then let's change the name from this bigger name to actually just one word, and let's see if that helps. But generally, if you save it on your desktop and then upload that file, it should be okay.
Okay, thank you, Paige. She said she had opened an Excel, saved, opened again, worked, saved it as a CSV, not as an Excel file.
Okay, it's generally okay. Usually doesn't have any challenges. What I've seen a few times is that Excel will add a blank line after a populated line. So sometimes you will get a lot of blank lines if you save data within Excel. But if you're not seeing that, you're good.
Got it. There was another question posted by Kian Okada. I was able to upload the CSV file, but when I tried to open it, it errored out with a message, row given with size different than 13, the number of columns in the table. So that actually sounds to me like a CSV parsing issue as well.
That's right.
If you try opening, if you open the file in Excel, sometimes it tries to smartly guess what you're trying to do with it, and it might like spread out the data to more columns than should be in there. So that's probably KN Okada, if you could try saving it as CSV and not open it in Excel, hopefully that fixes the issue for you.
Right.
I'm not seeing any other questions at this time.
That's a good sign.
And a quick reminder, if anyone else is still missing the Colab link, it's just search for Google Colab in your browser. I've also, if you go to the session Q&A and look at the first pinned question, it has links to both the Colab and the dataset.
All right, so should I start moving a little bit ahead?
I believe you can continue.
Yeah, Zia, I think you can continue. We seem to be stable.
Okay, great. All right, so again, this is pandas, and we are going to use a lot of pandas today. So when we start working with any kind of challenge or any kind of coding challenge or coding problem or coding functionality that we're building, and if we plan to use a library just like we are going to use pandas in this case, the first step is that we need to import those libraries within our code. So the first step that we are going to do here is we are going to import two libraries. I'm going to import pandas libraries, and you import it by just calling this import function and saying that I'm going to import pandas as, and we will give it a nickname of PD. So that whenever we have to refer to pandas, instead of typing the whole pandas, we will refer as PD. The other library that we are going to import is matplotlib.pyplot. It's a graphing library, and what it does is it helps you build graphs. So we are going to use this matplotlib to actually build a couple of graphs so that we can see the data a little bit. And we will give it an alias or a name of PLT for convenience. So we will import matplotlib.pyplot as PLT. Now this last line here, the third line here, starts with a modulus or a percent sign. And it's more like an escape character. So it's the percent sign matplotlib space inline. What it is telling the notebook is that this is not a Python command for running something, but it is more for the notebook to build the graph that they are going to build using, the notebook is going to build using matplotlib within the notebook. We don't want you to build it into a separate window. Make the graph within the notebook. So that's what this last line does. So percent sign matplotlib space inline. And once you have written these 3 lines of code, click this run button here. So once you click the run button, what you will see is that actually, in this case, you don't even see anything. Generally, in Notebook, you do get a star here or a number here, but in Colab, we do not get that number. So if you click on this and it runs and you do not have an error, we are good. What we don't want is errors. But if, for example, if I change the name here and misspell this name, we will see this error. So if you have an error, then we have a challenge. By plot, and once I remove this error and this cell instead of being black or green would be a red. I rerun this cell. Now I do not have an error. So there is no error, and that means that we are good. So let's do this, guys. Let's import these 2 libraries that we're going to use, and then we will read the customer data that we have. I'll give you guys another 30 seconds to type these commands in. and then run it. And if you have any challenge, please feel free. This is case sensitive, so please ensure that all the commands and everything is case sensitive in Python. So just be careful with the cases. All right, so hopefully everybody is able to actually import the libraries. Once we have imported the libraries, then the next step is that we want to read the data. So I want to read the data that we had uploaded to this Google Colab. We are going to read that data into our code. So for reading the data, again, as I had mentioned, that we are going to use the pandas library. So we are going to do pd or pandas. So pd.read_csv. So read_csv is a function or a method built into pandas that actually helps us read the file, a CSV file, so comma separated value files. If it's an Excel file, there's a different function for that. That's read_Excel. If it's a SQL, it's read_SQL. So it's different functions that you can find within Python that will help you read data. And then you give it the name of the file. So in my case, it is machine space learning space loan space default space dataset.csv. So you have to give the extension CSV. And the parentheses around that kind of signifies that it's a function. And once you take that file and assign it to this variable called df, this variable now holds the data. And when I will run this and I call this variable, you should be able to see the data now. So you should be able to see a loan ID, gender, married, dependent, education, self-employed. So you should be able to see the data like this. So let's do this. Let's read the data. And please let us know if you are unable to see this data.
Zia, we have a question from one of the attendees, Jessica Lamb. She's seeing a lot of blank rows in her data set. Do you have any suggestions on that?
Yeah, I think the simplest would be that if she can actually download the data again and not like just upload it without opening the file. So yeah, that's typically what Excel does, is that it actually creates blank lines. So download the data because we can drop it in here, but then that would probably be a little bit more time consuming. The easiest is that if Jessica, if you download the data again and save it and upload that new file, so that, but please don't open it in Excel. Hopefully that helps.
Thanks, Zia. Jessica said she'll try again.
Okay, great. Yeah, and if it doesn't go away, then we can run a command that will drop the lines, most of them. No other questions, Artie?
We have one other question from Wisdom. They're asking, so we don't need to specify the file path when using the pd.read function?
A good question. So in this case, because we uploaded the file, we do not need to specify the file path. When you are doing it, when your file is on your laptop and you are running the notebook in your laptop, in this case, because we are running it in Google Colab, there is no option to actually get the data from your laptop. So you have to upload the file either in your Google Drive or to this instance.
So I uploaded it to the instance, or we all uploaded it to the instance. But on your laptop, you will require to give the path, unless you put it in the same folder. But if it's not in the same folder, you do need the path. And the path goes right before the name of the file. So whatever it is, user / whatever. So you will put the path here just before that. But good question.
Just a note to everyone, reminder, if when you uploaded the file, if you happen to change the name of it, you want to make sure that that's the name you're using here. Because if you imported the data set exactly as we provided it to you, that's the name Zia has up there in the machine learning loan default data set. If you ended up changing it in any way, removing spaces, etc., then please modify it accordingly.
Good point.
We have a couple more questions, Zia. So for one of the users is getting an error. Module pandas has no attribute read.
So it's read_CSV. So let me insert a cell here. So so when you're typing it, it should be pd.read_CSV like this.
Great. And does a single quote versus a double quote make any difference in the naming of the file?
Does not. So if you start with a double quote, you just have to end with a double quote. But doesn't matter if it's single quote or double quote.
And we have one more question from Bharat. Can we read the files from online websites?
So can you? Yes. You can definitely read files from Google Sheets and stuff like that. Absolutely.
And we have an update from, oh, go ahead, Zia.
Sorry, I was just going to add that, yeah, there are different modules also that help with that. But yeah, you can definitely read from online.
Great. And we have an update from Jessica. She was able to re-download and re-upload without opening it in any way, and it worked.
Awesome. Good stuff. All right. So no other questions, Arti, now?
I'm not seeing any others.
So that means that
Yeah.
people are able to see this file. So so guys, this is the data set. So if you scroll to the right, we see the last column, which is loan status, and we have different columns. And if you scroll down, you see that this data set has 614 rows and 13 columns. So it gives you a snapshot of your data. So you get an idea, okay, this is the first 5 rows, these are the last 5 rows, and you have these dots in between, which says that there is more data in between. If we wanted to see more, we can see more. But let's look at it more like a programmatic way than just kind of looking at it line by line kind of thing. So once you have this data, you have imported that data inside the notebook. The next step, or the first step generally that you want to do, is you want to take a snapshot. I can see the data here, and it has these columns, and it has lots of values in there, but it doesn't really give me the full picture. I want a snapshot of what my data has. So in pandas or in Python, the snapshot you can get by doing this function info. So remember, df was what has the whole data now, this variable. So on the df variable, I run this function info. Now info tells me how many rows I have, 614. And it starts with index 0 and goes till index 613. And that's what we saw here. The last row is index 613. So it starts from index 0, goes till 613, and it has these 13 columns. So it says data columns 13. And these are your column names: loan ID, gender, married, and credit history, property area, loan status. So these are all your columns, the name of the columns. This is how much data is filled in. So it says non-null, which means not blank. So these are not blank. So when you see 614, that means every row is filled in. Every row has some data. Now, good or bad, that's a different story, and we will get to it a little bit later. But it has some data. When it says 601, that means we are missing data for 13 rows here. 13 rows do not have information for gender. Similarly, for married or not married, we have 3 or 4 missing. So this kind of gives you an idea of how much of your data are you missing. Because missing data, you have to treat missing data some way, because algorithms cannot handle missing data. So you, as a data scientist or as a data analyst, you have to make sure that there is no missing data. And the last column here actually is data type, which is objects, which is primarily strings. We have integers, we have floats. So we have these different types of data, but this will give you a snapshot of your data, that this is what we have as a data set. 13 columns, 614 rows, and some rows have missing data, but we have some rows that have everything filled in. I will give you guys 30 seconds to get this typed in and get a little bit familiar with this. Any comments on the chat or any questions?
Nothing I'm seeing at this time. Let's see. Well, Anna is having trouble uploading the file. So Anna, maybe I'll reach out to you offline to see how to upload the data. One other suggestion is I'm also following along on the tutorial live, and on the links to resources, I just shared my collab folder or my IPython notebook. So you can take a look at the code and copy it off of there if you still have any trouble with it, in case that helps. So make sure you look at the session Q&A. There is a pinned question, and I've just updated it with the link to my collab notebook.
That's great. Thank you, Artie.
Oh,
all right.
Zia, sorry, one other question. Pradeep is asking, how does it decide to identify an object as int64, etc.?
Good question. So, so in pandas, when it reads that, because it's a CSV file has no information about what is the type of the data. It doesn't say it's a string. It doesn't say it's an integer. It doesn't say. So pandas actually guesses it, and it defaults down to the lowest common denominator. And by lowest common denominator, what I mean is that if all the data is a float, but there is one integer, it actually defaults to that integer. If everything in your data is a float and an integer, but you have one string, because string is the lowest common denominator in that, it will default to that. And most of the 64 bits will take all of these as int64s. You can specify yourself, you can hard code it yourself if you want a variable to be not int64 but int8 or something like that. You can hard code it yourself. But when pandas is making an assumption, it will assume 64-bit. All right, so now we will move to the next step. So we have a snapshot of the data that told us that what do we have in the data set. So we have these columns. Now, it's good to know that we have a column for gender, but how about finding out a little bit more about that column and trying to see that, okay, what is this gender have as values within that? So we want to go a little further, and we want to find out that, okay, we have this column gender, but I want to find out a little bit more about what does gender have within itself. So again, in this is where we kind of start the analytics piece of it. So in pandas, again, there is a functionality called or function called number of unique. So n unique. So we're going to say that from the data frame, look at the column gender. So df.gender dot tell us how many unique values are there. And once I run this, it shows me that I have 2 unique values. So gf.gender.nUnique tells us I have 2 unique values. Now, it's good to know there are 2, but I am more interested in finding out, okay, what are those unique values? 2 is nice to know. So instead of doing n unique or number of unique, you can actually run just unique. And unique will tell you the unique values. Now, once you do the unique piece, you see that there is male, female, but there is something else which is called n, which is NaN. And NaN in pandas terms means not a number. So we have 2 values, male, female, and we have some not a number also. Now, if you scroll back up here in info, we saw that there were 601 that were filled in. So there were 13 that were empty. And that 13 is what we see here that is highlighted with not a number. How can we confirm that? And how can we take the next step? Is that what if we wanted to find out, okay, how many males, how many females, how many not a number? You can actually do a function called value counts. It's basically nothing but a group by function. So it groups by on these values, and it tells you that you have 489 males, 112 females, and 13 we do not know, or it is blank, not a number. So in this way, you can dig deeper into a column to find out what values does that column have. So I'll give you guys another few seconds to actually kind of get those 3 lines of code in there. And again, please feel free to let us know if you have any questions.
Zia, we have a more general question
Sure.
from Annalise Burburn. At work, we do not like to work with Google for security reasons. What would be a good alternative for Google Colab?
You can actually download Jupyter. So the notebook that we are running is actually a Jupyter notebook, and Jupyter is spelled as Jupyter, not PI. So it's Jupyter Jupyter notebook. You can actually download the Jupyter notebook on your laptop and run it there. If you use what's it called, Visual Studio, Visual Studio has Jupyter notebook in there. If you use Visual Studio Code, Visual Studio Code has it also. If you use other IDEs, they are starting to build Jupyter notebooks in there, because Jupyter notebooks are what most of the data science people like to run with. It's very convenient. You can see the result and you can move along. So yeah, you have these options. You can definitely, you don't have to use Google Colab. But for setting up the Jupyter notebook, you have to set up the Jupyter notebook a little bit, Python environment and all that. This is a lot more convenient running it in the cloud.
And Zia, on Mac, is it Anacondas?
So Anaconda is actually a distribution of Python that includes Jupyter Notebook as a tool in it.
Understood.
So yes, you can install Anaconda, that will install Python for you, as well as Jupyter Notebook, and you can do it for Mac and Windows both.
Oh, perfect.
Yeah. All right, so moving along. So this is, we looked at a little bit about gender. Gender, if I go back to the info, was a column type of object. So we saw how we can dig a little bit more deeper into an object column. How about a float or int column? How about a numeric column? How can we dig a little bit deeper into a numeric column? So in numeric columns, we can take mean, we can take median. So we can run this, we can find the applicant's income mean, we can find the applicant income median, and there's I'm confident that everybody is familiar with the difference between mean and median. So mean is the average, median is the center point. So we can find both those, and you can see the difference. The average is 5,403, the center point is 3,812. So they are a little bit different, and they signify different things. Average is kind of skewed by bigger values or smaller values. Median is the center point. But there is, in this way, you can actually do individual columns, but there is a built-in function called describe. And the describe function actually allows you to get mean, median values for all the numeric columns. So if I run this describe functionality, you will see that we have applicant's income, co-applicant's income, loan amount term, credit history. It actually does the mean here and the median, which is the 50th percentile, the center point, for all these columns, all the numeric columns. So it actually gives you these values for all the numeric columns. So describe is another way of actually finding that. Okay, so I will let you guys get to this point.
Zia, we had a couple of questions. So Garrick White is asking from one of the earlier pieces of code, passing the drop NA equals false into the value count function, is it telling the function to not ignore the NA values?
That, did I mute myself? That is correct, yes. So if you remove this and you run it, it will not show you the null values. But if you put it back in here, now it's not ignoring the null values. And once you run it, it will actually show you the nulls as well. So you're right. It is actually telling the function that do not ignore the null values.
Khalil is getting a different output. The NA values is 1241, the male is 489, and female is 112.
Yeah, so so Neil, I believe when you look at your data here like this, you would have a blank line in between. Can you please check in when you call the data like this df, do you have any blanks in there between two rows? So between index 0 and index 1, you will have index 0, index 1, index 2, and this will show in index 2. And if that's the case, what happened was that when you uploaded the data, it actually induced some blank lines in there, and that's why you have a higher number of blanks in here.
And then we have another an observation from Jessica that it looks like it's interesting that Python is really code sensitive. False with like all small letters is not the same as false with like camel casing, where F
Absolutely.
is.
It is case sensitive. So if I change this F to lowercase f, first of all, it's not blue anymore, and this will not run. So absolutely, it is case sensitive. This false has to be with an uppercase F, or starts with an uppercase F. That's absolutely true. Good observation. Now these are the column names. So these have to be exactly the same as you see them in info. Again, case sensitive. So if it's this applicant incomes A is uppercase and I is uppercase, you have to do it exactly the same here.
And one last item, Perry commented that it's nice that Colab supports tab completion.
Yes, it is very handy when you have large names that you can actually do tab completion. So when you type something, it will give you hints on what you're trying to type. Very good. So Arti, let's take a 5-minute break. Let's give people a couple of minutes to actually fill up their something to drink, fill up the bottles and stuff. And then we will get started on, so I'm kind of, so this is a little bit of descriptive analytics that we were doing, and now I'm going to switch gears and start going a little bit more into the data. So let's give people a 5 minutes break and then we will get started. In the meantime, if anybody is behind, they can catch up also.
Sounds good. Thanks, Leo.
Thank you.
And everyone, if you're still having trouble uploading the data, or if you have any other questions, please let us know in the chat, and we can try to help you.
All right. How's everybody doing?
So Zia, we have a couple of questions.
Sure.
One issue, Abdur Mahmood got an error while running the DF. The name error was name PD is not defined.
All right. So I think I got the name Abdul. So Abdul, you have to run this cell, the first cell. Please rerun this cell. So where it says cannot find PD means that it is unable to find this abbreviation or the nickname PD or alias. So rerun this cell. Actually, maybe you want to rerun all the cells again. So just go to every cell, just rerun the cell, and then you should be good.
We had another question from Bharat. Can we do a drop NA on the describe code?
So describe, I'm just trying to understand that how that will help, because describe actually tells you, okay, so that's a good question. So Bharat, what you can do is you can actually do here. So drop NA from within describe is not going to help you because it really doesn't tell you anything. You can see the count here. So the count is 614, 614, 592. So you know that you have blanks. But because it's a number, it treats those blanks as nothing. So it's not, it doesn't do that. So drop NA does not work within the describe function. It is not one of the valid inputs that you can provide or valid parameter that you can provide to a describe, because it actually gives you this information within the count here. There are a few other things you can do. You can actually change these percentiles. You can change what variables or what columns you look at. Those kind of things you can change within describe, but not the drop NA. Hopefully that answers what you're looking for, but if not, let me know and I'll try to answer that piece.
Thank you, Zia. We have one other question from KN Okada. Is there an option in Panda to read in an Excel file instead of CSV?
Absolutely. So I'm actually just going to insert a code cell here, and you can do pd.read and then Excel. This will read an Excel file.
Okay, thank you. And Bharat responded and said he understood.
Great. All right. If nothing else, then let's get to the next step. So this is our data, which is in DF. And let me just do a code cell here, and let me just call the data DF. So when you call the variable that has the data, you can see all of that data. Now, there are a couple of things that you can also do. So there is a functionality called select data type. And you can actually select your object data or your string data separately from your numeric data. So you can actually say that include objects and exclude objects. So I'm saying that within my data set, select the data types that are just objects, or just objects, correct. So these are my columns that are just objects: loan ID, gender, married, dependents, education, self-employed, property area, and loan status. And these are my columns that are not objects. So these are basically numeric columns. And if you can look at those: applicant income, co-applicant income, loan amount, term, credit history, all these are these are not objects, so they are numeric columns. So this is another way of actually segregating the two, if there is a need ever to actually separate the two. Sometimes there might be a reason that you don't want to look at the object columns and you just want to look at the numeric ones, or vice versa. So this is what you can do with that. Now, in the data, we have a lot of columns that have values that are like this. Male. So gender has this value male, and then it has the value female, and then it has some blanks. Now, what the algorithms do not understand is these algorithm doesn't know what is a male versus a female versus something else. Or in education, we have graduate and not graduates. So algorithms do not know that. We have to convert them into some kind of a number. And there are different techniques that you can do that. And there could be one technique that's more better than the other ones. So all of that you have to look at. But for right now, let's take it one by one column. And we are going to use this gender column and see what can be done for gender. So where was my, sorry, I'm just scrolling up a little bit just to show you guys that within gender, I have these three types of values. We have male, we have female, and we have not a number. So I want to convert this into numbers. What we are going to do is we are going to probably convert it so that male, we will say, okay, we'll just assign a 0 for a male, 1 for a female, and we can assign something for a not a number as well. So how do you do that? So in Python, generally speaking, you will write a for loop to actually iterate over your data and do that. In Python, there's a function called map, and map is just a for loop. Think of it just like a for loop. So it iterates over that. So what I'm saying to the algorithm is that, or to the data is that, okay, take this variable df, take the column gender, run a for loop, and for each value when it is male, so if the value is male, put a 1. And if it is not male, everything else, I want you to put a 0 for that. So we are going to replace 1 for a male and 0 for everything else. And this is called a lambda function. So it's like a one-line function in which I did not want to define a function separately and run that. This is just a one-liner that I will use. It will take every value within gender and actually convert that value into a 1 or a 0. So let's run that. And let me insert a code cell here underneath. And what I'm going to do is df.gender dot describe so it gives us an idea that we have 614. So if we scroll up here, oh, sorry. Yeah, gender had these 13 missing. So I am just trying to ensure that we have no missing in gender. So that's one way of finding it out, that we have everything. So the minimum is 0, the maximum is 1 because we replaced everything between 1 and 0. And we have this values filled in for or replaced. For a male, we put a 1. For a female, we put a 0. Now, this is a lambda function that we used for the column gender. We can use the same lambda function for other variables as well. So you can copy this line. I am actually going to insert a code cell right underneath this. And what I want to do is there is a column called merit. So on the merit, I want to find out what unique values do we have. So if you look at the merit unique values, it has the same thing. It's no, yes, and nulls. If we do what was value counts, and again, if we say drop NA is equal to false, it will tell us how many of each. So there are 3 values that are missing, and there are 398 married, and there are 213 not married, and then there are 3 missing. So again, you can copy that same lambda function, it's exactly, instead of male here, it's a yes. So if it's a yes, you put a 1, else you put a 0. And this is how we are going to actually change yes and no into zeros and ones. Very similar to what we did for gender, where we changed male and female to zeros and 1. We are going to do it for married as well. And when we run that, this should actually replace the values. Now we are going to do, sorry, go ahead, please.
Sorry, Zia, we have a couple of questions on this. So
Sure.
Bharat is asking, can we use this exclude feature to remove columns from the data set?
You certainly can. So I'm assuming that he's talking about this. So you can certainly use exclude to exclude columns from your data set. So you can take this, but remember, this is basing it on data type and not on the column name. There are other ways to do it to exclude column names, but this specific function select underscore data types is actually basing it on the data type and not on the column name. And I think I do the column name exclusion later, so I will get into that for sure.
Got it. And then Christian and Jessica are asking, so in this df gender where we are doing the lambda x, so if x equals male, then 1 else 0, did that also convert the NA values over to 0?
Good question. So how do you check? You so I inserted this there, and we want to find out if there is a null there or not. So we say df.isNull. So that will tell us that if the value is null or not, and we do sum. So we want to add all of them together, and then we run it. So you see, these are the two columns that we actually converted: gender and married. And there is 0 null values in both of them. Dependents we have not. The next one that I'm going to do is loan status. It doesn't have any nulls actually in loan status. But dependents, so the ones that we have not done, they still have some missing values. But in gender and married, we have done it, and there is no missing values in there. So that's why it is missing is null. And then there are different ways of doing it. You can actually specify different. You can actually say that for x is equal, when x is male, I want a 1. When x is female, I want a 2. When x is null, I want a 3. So you can actually do it that way also. So there are many different techniques that you can use to actually fill those or convert those values from a number to a from an alphanumeric or a string to a number.
So Zio Christian's asking a clarifying question. So is this overrepresenting females then, because there are 0 values in gender?
Right. So yes. So I think what he's referring to is that did we convert these 13 into females? That is correct. So it does convert these 15 actually. You see, zeros is 125. Earlier it was female and male, and it was 113. So we did convert those into females. Now, if that is something that you do not want to do, you are absolutely, that's what I was saying here was, you can actually change the lambda function in a way that it does 1 for male, 2 for female, and 3 for nulls. So correct, it does increase the population for females, but we have an option that if we do not want to do it that way, we can do it a different way. Hopefully that helps.
Yes, we have a couple more questions.
Sure.
From Bharat. So we did not replace the NaN for gender and married, so we should see some records question. So he's asking, should we see some records?
So I'm not sure if I get the question exactly, but I think what he's mentioning is that we did not convert the nulls. No, because I did it this way, it did. There are other ways of doing it where it will not convert the nulls if we do not want to convert them. But I wanted to do it a little bit simpler. So that's why I did it this way, so that it does convert the nulls also. So we have converted the nulls in this case. But if the question is that can we not convert the null? Absolutely. We can say that we don't want to convert the nulls. We want to leave the nulls as is. Or we can actually say we want to fill the nulls with something different. We want to say 3. But we have to convert it into a number. So our choice is either we increase it to a male population, female population, or give it a different number.
Thank you. So Joshua Huntley is asking, could you please demo the lambda syntax?
Demo the lambda syntax. Okay.
So maybe just go over the loop.
Correct. So what lambda does is that it actually, because it's running underneath this for loop, so what it does is that the for loop gives the lambda one value of gender each time. So it will give it male. Now, what the lambda does is that it takes that value from gender and puts it in this X value. So the value of X becomes now male. Then it goes into this if condition and say, if X is equal to male, I will, so what you have to put in is before the condition. I will put a 1, or we are saying that you have to put a 1 in there. And for everything else, put a 0. So lambda, take the value from this gender, put it in the X, and then evaluate on this X. Does that help?
Okay, I haven't seen any response yet on that.
Sure.
So a couple of questions from from Joshua. So the syntax for choosing male. Oh, okay. So he's looking for clarification on if we wanted to divide up male equals 0, female equals 1, and NA values equals 2. How would we do that here?
Oh, okay. I got that. Okay, let me see if I have something like that in this. Where is the nulls? Okay, so let's see if dependence has any nulls. I can go and redo the, oh yeah, there's the dependence. Okay, so dependence has nulls. So I'll show you, Joshua. So give me 2 minutes. I'll show you in dependence how to run a. So I understand you're trying to see how can you do a multiple if statement. So yeah, I'll do that with this dependence. So give me 2 minutes. Let's see everybody else is okay till here, and then I'll show you the syntax for that.
Okay, and then Perry had a question on. He still is showing 3 under the married. So what did I miss? Is what he's asking.
Okay, so what did okay, this married this one. So he's still showing 3 in the nulls.
And Perry, actually, I had the same issue, if that helps you. I just had to make sure that the code snippet that Zia is on, because I'd copied it over from the gender line. So I still had df.gender. So if you don't, you have to make sure that all of that code is properly replaced and that the X equals yes.
Good. Thank you, Auntie. Yeah, that's good observation.
Zia, one other question.
That to married also. Sorry, go ahead, please.
Oh, one other question from Christian. So he's asking, wouldn't we be able to keep the NA values and still have the variable be a numerical data type? I feel that this would maintain the data integrity and not skew calculations based on these categories.
Yes, so we can do that, certainly. Again, there are many different ways of filling it in. So in this, I'm kind of achieving two goals. I am actually changing it from a string field to a numeric field and also filling the null values. Can you do them separately? Absolutely can do them separately. There are different methods of doing it. But eventually you have to keep in mind is that eventually you have to treat the nulls. Whatever way you want to do it. You want to drop them. So what are the options? So for example, if we just not convert the nulls in this case, and we leave the nulls as is, what are my options for nulls? My option is I can drop the nulls. My option is I can fill the nulls with 0. My option is I can fill the nulls with mean. I can fill the nulls with median. But I have to do something about the nulls, because if I don't do it, the algorithms wouldn't be able to run. So I have to treat them one way or the other. Now, does that bias your result one way or the other? It sure does, because you are increasing one where you are, or the data was not sure that if it was a male or a female. So it does do that. So when you are doing data science, sometimes filling in the missing values or how to treat the missing values is a bigger task than what we did in 2 lines of code here. It's a bigger task because you have to ensure that these things, whatever the value is replaced, is actually representative of what you want to replace. But yeah, absolutely a valid point that it does bias the result a little bit, and we have to fill those values in a little bit carefully. All right.
I think we seem to be in a good place.
Great. All right. So moving along, the next step was loan status. So I wanted to convert the loan status into ones and zeros, because the loan status, actually, why don't we just do it here? So the loan status has values. So we want to find out for loan status, we want to find out the unique values. So within loan status, the unique values are y and n. So it doesn't have any nulls in there. So we'll just change same lambda function with loan status column, and we will change the yes into a 1 and no into a 0. So that's how we will convert the loan status from yes and no to 1 and 0. Now, the next column that we will handle is dependence. And with dependence, the unique values that we get are 0, 1, 2. It's not 3, it's 3 and plus. And what this plus does is that it actually converts this into a string. So that's why you see these commas here, is because now all of these values are a string and we have some null values in here. So we have to now do, again, 2 things. We have to convert the values from a string to a number, and we have to ensure that, because this 3 plus is not going to be able to convert into a number. So we have to treat the 3 plus also. And then, of course, we have the nulls. So we'll take a 2-step approach. The first step is we will change this 3 plus to just a 3, so that it becomes a 3, and we can then convert that into an integer. So within the dependent column, I'm going to replace the 3 plus with a 3. So this is how you can replace something, with a different value. Now, within dependence, I'm going to take a different approach and not do it this way where everything else became a 0. I'm going to fill the nulls with 0 first. Now, do I need to fill it in with 0? You don't have to fill it in with 0. You can actually fill it in with the mean value. And you can find out the mean value for the dependence. That, okay, what's the average value? And you can fill in the average value with that mean. You can also say that, okay, I do not want to fill it in with anything. I just want to drop those rows. So instead of saying fill any, you can actually drop those rows and drop the null rows for me. So you can actually say drop NA. So again, it's an answer that requires a little bit of business knowledge. That's why in my initial slides, I had that you need to understand the domain. So based on the domain, based on the work that you're trying to do, you might have a different thought process in filling those values in. But whatever the value that you want to fill in, you can actually use fill NA to fill that value in there. You can actually fill it with mean, median, 0, or whatever you like. So we are going to fill the values in with 0 for simplification, so that it doesn't become too complicated. We will replace. So what we have done now is we have replaced this nulls with 0 by doing this fill NA, and then so once we do that, I'm just trying to see where the lambda function is. Okay, so this way I didn't do a lambda function. Okay, no problem. So we filled in with 0, and now let's run the df.info. So look at the df.info and the dependent column. So dependent column is still an object. So we did change this from 3 plus to 3, and we filled everything else with 0. It did not change the type of the column, whereas it did change the type of the column here. It did not change the type of the column. So in this example here, what I have done is that I have just converted it into an integer, dependence into as type an integer. So it actually converts the dependence column from an object to an integer. But because there was a question on that lambda, how do you write a lambda where you have multiple conditions? So I'm actually going to write a lambda function here so that everybody can kind of get an idea of how to write multiple ifs there. So we have the values for unique are, so I'm going to rerun this cell. So the value for uniques are now 0, 1, 2, 3, and this 0. So this 0 is what we replaced. And this 0 is an integer and is not a string. So that's the difference between the two. So we are going to run a lambda function for this. So this lambda function is going to be df.dependence is equal to df.dependence. So it's the same thing till here. We run a for loop. So map, then we do a lambda, and then we do a x colon. So till this point, we have done nothing different. It's exactly the same. Now we have different values. So we have the first value is 0. So we want to say that it will be a 0 if x is equal to 0. So now this is a string 0. It will change it to an integer 0. Now we say else. Now earlier we were doing else, everything else we were saying was a 0. Now we don't want to say everything else is a 0. Now we want to say it's going to be 1 if x is equal to 1. So convert this 1 into a number 1. And then we say else, sorry guys, this, it's good that it provides you help, but then too much help is probably not very good. Else, and you have to spell the else right, else, we want to say that we want to put a 2 if x is equal to 2. And then we say 3, then we say else 3, and you can go on. Actually, I am going to let you guys finish it so that you get some practice. So finish it and then rerun the unique just to make sure that we have those values. I'm not going to finish this so that you guys can do it on yourself. So please try, and then if you run into any challenges, then I'll finish the statement if need be. Please keep in mind this 0. This is different from this.
Zia, we have a question.
Sure.
Oh, okay. Paige just commented that she wasn't able to load the file anyway except by saving it in Excel as a CSV, but she found a way to delete the blank rows and she's pasted some code.
Oh, okay. To do that. Okay, great. Thank you.
Not seeing any other questions so far.
Good. So so this is the whole statement. And now I ran the unique on that. So now we have integers 0, 1, 2, and 3. So I'm hoping that everybody is good till here. So if you have any questions, please feel free to put it in the chat. If not, that's another way of actually converting a column into an integer column, is where I converted that into an integer. But since we did the lambda function, we do not have to do this piece. And then the last step here, or the last conversion that I'm doing here, is that I'm taking the credit history and filling the credit histories, which were blanks, so nulls, NAs, with 0. So just replace that, fill NA with 0. Again, you can do it with you can do it with a median, you can do it with a mean. It depends on your business requirements and business thresholds that they have. All right, so this kind of brings us to one layer down. So we had the data, we actually kind of looked at the data, we analyzed the data a little bit, we then prepped the data so that we took some of the columns and converted those columns into numbers so that we can use those with the algorithm. Now, the next step here is that we want to select some of the features from within our data set to actually really build a model. So in the math, or in statistics specifically, there is a concept of correlation. So we want to find out what is the relationship of one column with the other column. So we want to get an idea of that correlation. So on my data set, if I run a correlation, it will give me correlation of each column with another column. So I have these columns. So I have gender, which we converted, married, dependents, applicant income, co-applicant income, loan amount, loan term, credit history. We have all these columns that we can use. Interesting. So I did not. So that's important, guys, that if you have some code, you need to run it. I did not run this. So that's why we didn't see loan status there. So we will run the loan status. So let's look at the info just to make sure that it's a number. So loan status is an integer now. And let's rerun the correlation again. So now we can see that we have loan status here. And if I scroll to the right, we have loan status here. So this is the correlation of gender with gender is 1. Gender with married is 0.39. Gender with dependents is 0.14. So it gives us correlation of every column with every other column. What we really want to find out is the correlation between every column and loan status. So this is our column loan status that tells us if the customer paid back the loan from our historic data or did he not. So this is the relationship of every column with loan status. And of course, loan status has a 100% relationship with loan status. And everything else is a little bit different. Some of them are negative, some of them are positive. Negative means it's an inverse relation. It's not good or bad, but it's inverse. Positive means it's positive. I can actually sort it also. So I can actually say sort underscore values, and it will sort the values based on that. So when it sorts the values, the negatives come at the top, but I want them in descending order. So you can actually say ascending is equal to false. So now it's in descending order. So credit history has the biggest relationship with loan status. Now there could be some inverse relationship that are strong also, so you have to keep that in mind. But right now we see that credit history has 0.43 or 43% correlation with loan status. So generally speaking, data science people look at this correlation and see, okay, how much of this variable explains my target variable, which is loan status in our case, the variable that tells us if the customer paid back the loan or not. So depending on this, it tells us that what kind of value do we see in terms of relationship between those. And this helps us select features that we want to use in our model. Can we use everything? Sure, we can use everything. But can we use some? Yeah, based on this, if the feature is more related to the other feature, we can use that feature. So let's pick from this data, let's pick a few features that are helpful. So let's pick credit history that had high correlation. Applicant's income, it shows a little bit less correlation here, but how much money you make should have some impact. And then I picked the first two, so credit history and married. So here is the married. And then loan status is our target variable. Loan status is the variable that tells us that if the person actually paid back the loan or did not pay back the loan. So it kind of gives us that idea of is it a customer who paid back the loan? So good chances that if their customer is like this, they will pay us the loan back. So we picked these 4 columns from this data set. So I have picked credit history, applicant's income, married. So the top 2. And then after that, I actually included co-applicants, applicant's income as well. We could pick a different column also. It's absolutely fine. But what we wanted to do was make a selection on the features that we are going to use to run this algorithm. So we picked that, and we actually took all the columns away, but besides these 4 columns. So I said from the data df, select just these columns. I don't want everything else. And I will take that and put it into a new data frame. So earlier there was a question that, okay, if I just want a subset, or the thought was that if we just wanted a subset of that, how can we do that? So this is one way. Again, that's not the only way. There are many other ways of doing it. But this is one way of getting a subset of the columns, is that you can actually pick what you need. So let's pick these columns and assign that to our data. So now when you want a snapshot of your data, what you do is you do info, and info tells us that we have this column credit history, applicant income, merit, and loan status. And all of them have 614. That means everything is filled in, and all of them are numeric, so either float or int. So this is our data now. So we went from those 13 columns now to just 4 columns to see if we can build an algorithm. After this, once we have kind of selected our features, the first step after that is we want to separate the target variable. So in our case, the target variable is loan status. Target variable is also called the dependent variable. So we wanted to actually separate the dependent variable from the independent variable. So the top 3, credit history, applicant income, and merit, are independent variables, and the last one is a dependent variable, which is loan status. So what I did was I created a new data frame from within this data frame of data, and I picked credit history, applicant income, and merit in X, and Y is loan status. Now, did I have to do this step in between? You don't have to. You can actually, we could have easily said that X is df and these 3 columns, and Y is df and this loan status. So yes, is one way better than no? It's an extra step that I did, but just to kind of highlight or showcase that this is how you can select columns and deselect columns. So we have created these 2 variables. One of them is X, which is primarily independent variables, and then Y, which is the dependent variable. Y is the variable that we want to predict. We want to predict what is the status of, what will be the loan status of this person. And I'll get into that in like 2 minutes. This is what we want to predict. And this is the variables that we are going to use for our model. So once we have separated the independent and the dependent variables, the next step is, so make sure that I run this, and then once you get where you have the independent and the dependent variables, then you get into the modeling phase. So in the modeling phase, I am going to use, actually, you know what? I will stop here for a minute before I get into the modeling phase. Let everybody ask any questions if there is anything that needs to be answered. If people have any questions, any challenges till this point, please let me know.
We had one of the folks ask a question. So Jessica is asking, she is seeing NA values for all of the df.core. Yeah.
Oh, here?
Yeah.
Okay. Okay. How about, Jessica, you try this command, try df and see what do you get. Like, do you have a data set like this still? There are no null values in there, or you can actually do df dot is null and dot sum and run this and see how many nulls do you see. Like in our case, we have no nulls for gender, no nulls for married, no nulls for dependent, no nulls for applicant income, and no nulls for, so if you have no nulls for these, other things could have nulls, but these columns should not have nulls. So try that and let us know, and I can answer something else for the time being while Jessica tries that.
Great. When I got Jessica's comment earlier, I'd asked her to rerun all the snippets from the start, just in case something got missed in the middle, and that seems to work for her as well.
Okay, great. Yeah, absolutely. Good point. Yeah, sometimes because we are actually running a remote session, sometimes the session actually breaks, and that can actually reset your kernel, and that actually takes the values away.
And Perry is asking, just to clarify, why is the dependent variable?
Why is the dependent?
So sorry, y meaning the variable like x versus y.
Oh, okay. So sure. Yeah.
I see how that sounded like a sentence.
Yeah. Now these are just names, guys. There is no reasoning that this has to be x and this has to be y. If you are a stats person, if you are a statistician, or if you have studied stats, there is this concept of independent and dependent variables. And generally speaking, they refer to independent variables as x and dependent variables as y. Here, the naming convention has no meaning like that. I am not using it that way. But because I'm not a statistician, but I have a little bit of a stats background, so I generally tend to make the dependent variable or the target variable as y and everything else as x. And the third reason is that a lot of us are familiar with that regression equation, which is y is equal to mx plus b. So in that case, y was the dependent variable. So there are a couple of reasons that we choose y for it. But again, there is no no reason to not name it something different. You can call it dependent, you can call it anything else as well. Hopefully that was the question, but if I didn't get the question right, please feel free, and I'll try to see if I can answer that.
Right. No, I think that answered the question. And Andy also added, y can also be a target variable or whatever you're attempting to predict.
Absolutely. Thank you. So are we good to move along?
Let me check. There's one new question.
Sure.
Wisdom is getting a loan status as NA after running the df loan status lambda code. Yeah, so this is the df loan status equals df.loanstatus.map. Lambda x should be 1 if.
Where is the loan status? Oh yeah, here. This one.
Yeah. Else 0.
Yeah, else 0, and this is an uppercase y because that's the loan status value. It's an uppercase y. Again, it is case sensitive. So just make sure that this is loan status. Yeah, Arti brought up this point earlier, and this is also loan status.
Wisdom, I'm not sure if you. No, the rest of your code looks right. Yeah, I guess my suggestion would be to try going back to like where we started doing the data prep and maybe running all of those codes again, or running the snippet from start all the way from the re-import. I think we're good. We don't have any other questions.
All right, great. So, and yeah, and Wisdom, let us know, and then if you still have challenges, we'll figure it out. All right, so now I'm going to start building using an algorithm to build this model. So the first algorithm that I've picked is actually an algorithm called a decision tree. A decision tree is basically a non-parametric algorithm that actually helps us in kind of, it builds a tree. And if the value of 1 is yes, it will go here, or 1, it go here, the zeros go here. And you build a tree and you go down the tree, and then you try to figure out which bucket does that fall in. So that's a decision tree. It's a good algorithm, and sometimes companies use it, but I just want to showcase a point here. So that's why I am using initially decision tree. So I'll get to that point in 1 second.
Zia, just before you start the section, there was a quick question from Garrick White. Are we going to normalize any of the dependent variables?
Good question, Derek. I'm using a decision tree. Decision tree is a non-parametric parametric algorithm. So what it does is it does not require normalization or standardization or normal distribution. It does not require any of those. And that's why a lot of times people use tree-based algorithms, because in real world, a lot of times the algorithm data is not normally distributed. And if it's not normally distributed, when you use a regression-based algorithm, their assumption is that you are using an algorithm that actually follows normal distribution. The data follows normal distribution. So since we are using decision trees, we really do not have to actually normalize. Can you do it? You can absolutely do it, but there is not a requirement to do it. So that's why I didn't do any normalization or standardization in this case as well. But if you are using a regression-based algorithm, then it is recommended. Or if you're using neural networks, then it is recommended that you normalize your data. Hopefully that answers.
Yes, thank you.
Great. Anything else, Arti, before?
No, I think we're good.
Okay, great. Thank you. All right, so again, going back to very quickly, the reason I chose decision trees is because it does not have that requirement of normal distribution, or normalization. So we are going to actually, we don't have to do that. Again, if you want to, you can certainly do that. We are going to use this decision tree algorithm. So in Python, they are available in this library called sklearn. So I talked about the library pandas earlier. Pandas is a great analytical library. It helps you create those data frames, read data from different sources, all that kind of good stuff. sklearn is the library name is scikit-learn, and scikit-learn is the library that allows us, or that has these algorithms built in. And from that library, there are tree-based algorithms, and I'm going to import something called a decision tree classifier. Now, why am I using decision tree classifier? Because the column loan status has two values. It has zeros and ones. It has a group of zeros and a group of ones. It has two categories. So that's why I'm using a classifier. I want to either classify the person as 0, no loan for you, or 1, yes, loan for you. So we are going to actually take these values and run it using this algorithm, decision tree classifier. Now, once you import the decision tree classifier, you have to initiate the classifier, and this is, you call the class, and then you can put some parameters, but we are going to leave the default parameters for now. And we say that, okay, this is our classifier, decision tree classifier, and we are going to call that classifier CLF. Again, you can name it whatever you like. I'm just, for classification, I'm just using it using CLF. So you import that decision tree classifier, you assign it to your to a variable name, that class decision tree classifier to that variable name, and fit is where you actually tell the algorithm to train or learn based on your independent data, which is credit history, applicant income, merit, and the result, loan status. This is the result, loan status, and this is the independent variables, and you're saying train or learn based on that. So you hit, you kind of run these. Now you see some, once we run this, there were some values in there. We can talk about that at the end if there's a little bit of time. But the algorithm CLF, or decision tree algorithm, in this variable CLF is now trained. Now we have trained an algorithm using our historic data, and basically the loan status variable, which was our target, and the independent variables, credit history, applicant income, and merit. We have trained this algorithm. Now the next step is, a customer comes to our website and he wants a loan. So we say, okay, Zia, you are here and you want a loan. So tell us these three things. What is your credit history? What is your income? Are you married? And based on those three things, the algorithm is going to decide, should we give him a loan or not? So let's do that. So let's make predictions. So credit history. So 0 means that there is, so by 0, I mean they have credit history. Okay. Credit history was 0 with credit history. So let's go back. Oh, we didn't, credit history, we didn't change credit history, it was already 0 and 1. Okay, sorry. So if you changed credit history, then you know, but that you have changed it. If you did not change it, then you are not, you should then have to go back to the database team and say, okay, guys, you have 0 in there. What does 0 mean? And those people might have put 0 where they had no credit history or where they had credit history. So in this case, 0 means that they have credit history. My bad. It means 1 means they have credit history. So this is not I, this is 1. So 1 means they have credit history, 0 means they have no credit history. Married, 0 means not married, and 1 means married. Applicant income, whatever the income is. So we are going to actually use these three values. So Zia comes to the website. He says, I'm not married, or I have no credit history, or sorry, I have no credit history. I'm not married, and my income is $4,000. These are the three things that our algorithm needs to tell us if we should give loan to Zia or not. And we take these three variables and we use the classifier that we build and we predict on that. So credit history, 0, married, 0, applicant income, 4,000. All these three values, when plugged in into this predict, says, do not give him the loan. So let me just insert a cell here so that everybody is kind of understanding what I'm doing here. So I actually did clf.predict, and then I said credit history is 0, married is 0, income is 4,000. Let's run this. All right, doesn't like it. Oh, it needs a shape. Okay. Let's run this. So you see, this information and this information is exactly the same. We asked the user three questions: credit history, it said no credit history; married, no married; applicant income, 4,000. And it says do not give him the loan. Maybe because he has no credit history. So let's change the credit history from 0 to 1. So the person that comes in has credit history, still not married, and still makes the same amount of money. So let's run this, still 0. Okay, let's make him a data scientist and give him a $10,000 salary a month. If hopefully that helps get him credit, still no credit. So this is how, when you look at different attributes, you can actually change married or not married and see if that affects. So nothing is giving you any value here. All of them are saying that we shouldn't give him any loan for now. And we'll get into that what is happening in this case. So now we have this algorithm. It's saying don't give loan to anybody. And we are like, okay, we don't give a loan to anybody. Bank is not going to make any money out of it. So how is the bank going to survive, kind of thing. So when you build an algorithm, the most important piece is that you have to test the algorithm. You cannot take this algorithm and put it in production and assume that it's going to work. Now, how do you test? So for testing, you have to again use the historic data. And what you do is you take the historic data, use the algorithm to actually see that how well your algorithm predicts on the historic data. Because for the historic data, you already know if they paid back or did not pay back. So we are going to test this algorithm that we built, the CLF, and see how well this algorithm does on historic data. So in testing, we are going to look at accuracy, how accurate the algorithm is, accuracy score. And from this library, sklearn, the machine learning library, we are going from metrics, we are going to import accuracy score to find out how accurate the algorithm is. Now we run this, we import this function accuracy score so that we can see or find out how accurate the algorithm is. Now what I am doing here is, remember this X that we defined earlier? This is all the independent variables. I'm saying use this algorithm CLF and predict on all the independent variables for the whole data set and assign it to this variable predictions or pred, and that I'm calling that pred to see if the algorithm says where it says 0, where it says 1. So let's run this. So it's saying 1 and 0, 1 and 0. Some of them are 1, some of them are 0, which is great. The algorithm, it looks like the algorithm is doing something. But again, we don't know how good this algorithm is. So our next step is to use this accuracy score and find out how accurate the algorithm is. So we call this accuracy score function. What is y? Y is the loan status that we defined earlier. So these are the true values. Prediction is what we predicted. And we are saying, can you, accuracy score, compare the two and tell us how many times are we correct? And the algorithm is saying we are correct 98.3% of the times. That's a very high accuracy. If your algorithm is 98.3% correct, that's really good. So we have built an amazing algorithm. Now we can go and tell our manager that, look, our algorithm is 98.3% and it took us like 20 minutes to build it. Anybody sees any challenge with this? What challenge, what can be, like, is there a problem or are we good? Can we go to the manager, bet our paycheck on this and say, okay, here's the algorithm, we are good, let's go live. So the challenge, guys, in this case is when we built the algorithm or when we trained the algorithm, we use X and Y, independent, dependent variables. When we are testing the algorithm, we are using the exact same again. So algorithm already knows everything. And this is one of the things that is not good about decision trees. Decision trees are absolutely great at learning everything. The challenge is when they get new stuff, then they cannot predict well. How do we know this? So because we built an algorithm that was trained on the same data and tested on the same data, the algorithm could be biased and may know the results already. So what we have to do is we have to separate the test piece and make the test piece as a true test piece, which is not seen by the algorithm at all. And this is where we have this function, which is called train test split. So again, from sklearn model selection, we will import train test split. And with using train test split, what we are going to do is we are going to split the data into 4 pieces: X train, X test, Y train, Y test. And we are going to say use this train test on the data X and Y and give us a test size of 20% and stratify the Y column, which is the loan status. So stratify Y. And based on this, this is our training data now, 491 rows. And this is our testing data, and we have separated the two. Now we are going to use this X train to train the algorithm and X test to test the algorithm. And now we built a new classifier. Again, same decision tree, but I changed the name to T_classifier because now I have used train test split. I'm using X train to train the algorithm based on the loan status of Y train. And once we, okay, you need to run all of those, sorry guys. So we train the algorithm. Now this new algorithm T_CLF is what is trained on this. And now let's check the accuracy of this. So I'm checking the algorithm's accuracy on Y train, again on the train. So look at the accuracy. Did I run it? 98.16. So again, when I use it on the train data set, it is amazing, 98% correct. But when I use it on the testing data set now, the data set that it has not seen earlier, the accuracy goes down significantly. This tells me that my algorithm is overlearned. It has learned too much from training, and it cannot predict well for testing. Now I know that we have covered quite a few things, so I will let you guys do this portion, code this portion along, and let me know if you can see. I don't know if I can increase the size somehow so that it can fit everything in there. Let me try. Hopefully you guys can see this, all of it now. Yeah, let's try this and get to that point. And if you have any questions, feel free to ask, please. I'm just trying to plug in the laptop. It's kind of low battery. And RT, you guys can still hear me, right? I didn't lose everyone.
Oh, we can still hear you.
Okay, great.
Yeah, you're good.
Excellent. Any questions, anything that people have? Guys, are you able to, like for everybody else, are you able to take down this code piece and
I think everyone's trying to type it in and see for themselves what you did.
Yeah, so we'll give them a couple of minutes to actually get that in.
Yeah, maybe guys, if you're ready for Zion to continue, you just post it in a chat. And those have already done, maybe you can take a water break or something.
Yeah, I was just going to say that maybe we will take a couple of minutes break so that people can. And it's almost 1 o'clock, so I do understand that it's already lunchtime or past lunchtime. Yes.
Zia, there was a request. If you could scroll down just a little bit for the accuracy check section.
This one or this one?
Those, yeah, where you are right now.
Okay. So in this, just to explain that I didn't assign a variable to it. I'm actually running the prediction right inside the accuracy check. So this is where you use the object-oriented kind of thing classes, and I'm actually predicting within the accuracy check. Earlier, I had a separate variable that I defined for predictions. This I'm checking it within the accuracy check.
So Zia, we got a comment from Angela, who says she got a different number for the Y train and the Y test. So she got like 99.389% for Y train and 0.626 for Y test. Yeah, excellent. Great question. When we do this function train test split on 80% training set and 20% size of testing set, this is, guys, a random split. Random split means that it will randomly pick. It's not sequential, because sequential doesn't make sense. You could have all the bigger values in one part of the data set. So it's a random selection, and the data set that you might have chosen for training might be different from what I have. So I think all of us might have different values for that. So it's okay, because this train test split will actually randomly pick rows for training and for testing. Generally, it'll be similar, because again, it's because of the random selection, but it's not going to be exact. And can you make it exact? Yes, there is a way, and that's called, there's another parameter in train test split that you can use to actually define your your seed. So you can actually specify a seed so that it does not change. But I didn't specify, so that's why everybody could have a little bit of a different value in there for accuracy. Zia, we have a couple of questions on. So Garrick is asking if you could explain the seed concept a little bit further.
Okay. So seed is basically that allows you to make the randomness less random. So select the same data points each time. So within this, if there is the parameter which is called random, I think it's called random state. Random state, and you can specify any number in there, 0. Let me just try that. I don't remember exactly if it's called random state. Yeah, so it is called random state. Random state, actually what it does is that it assigns, now I have assigned the value of 0 as the seed. So what that seed does is that it will actually now make these random selection consistent each time it runs. It's not going to change the rows, because it uses the seed concept, or seed. You can think of seed as a starting point. It uses that starting point concept. And I said 0. It does not have to be 0. You can actually put this number as random seed, and is absolutely fine, as long as you leave that consistent. So if all of us try random state as 0, and now let's split the data, let's retrain the algorithms, let's recheck the accuracy, and let's see if we all get the same numbers. So while people are trying that, Marty, you said you had a couple of other questions also.
There was one other question from John. Can CCP alpha increase instead of 0? Any difference?
These alpha. So guys, these are some, so I think he's talking about this alpha value here. So right. These are some of the parameters within the decision tree that you can change. You can change the alpha, you can change the class weights, you can change the, instead of Gini index, you could have different criterion for there. So if you look into this decision tree classifier, so just Google search decision tree classifier sklearn, it will explain to you what these are. And if you have a little bit of a stats background, you'll be able to kind of understand these
these parameters, but these are some of the options that you can set within within your decision tree classifier. So these are some of the parameters that you can set within the classifier. Oh, sorry, yeah, there was random state. So it said none earlier. Now, if I, why does it say none now? Interesting. Still says none. Oh, I set these random state for the split and not for the decision tree. So for decision tree also there is a random state. My bad, guys. So this result may still not be the same because we did not set the random state for the decision tree. So let's set the random state for decision tree also, and let's set it to 0. So now you see random state is 0, and now hopefully we should have all the same answers. But these are some of the parameters that you can specify within your decision tree. So you can change the alpha. There is a gamma also, which is not showing it. Maybe decision tree doesn't have that. But there are some advanced algorithms that will have it. And I'm going to use random forest next. So you will see that there are some other parameters that you can also define in there. So if you are curious to find out more about these parameters, just Google search sklearn decision tree classifier, and it will give you, if you go to that documentation, it will give you explanation on each of them.
So Zia, thank you for the additional random state on the decision tree classifier. I was getting a different number too, but
Okay.
now I have the exact same percentage as you do.
Exactly. Great. Yeah, thanks. Yeah, so there are 2 random states. One is on the split and one is on the tree. So we have to set both of them to actually get the same numbers. Sorry.
There is an additional clarifying question from Angela. When you set the random state equals 0, it doesn't mean the data starts at 0, but what was it instead? She missed the part of
Yeah,
what
so
it
not
means that the random state to 0.
Yeah, so it sets the seed. So what is a seed is basically when we have something random, in computer, okay, let me take one step back. In computer, there is really nothing is random. Everything it's ones and zeros. Everything is math. So there's no real random. So for us to actually create randomness, we actually tell the algorithm to generate a number and take that number and then multiply it with something else to actually create get a starting point. Now, when it actually randomly gets that number, we are saying that instead of getting that number randomly, use that random number generation from 0 as 0. So it's kind of setting so this is called a seed. So you actually kind of set that seed in your algorithm that whenever you are generating a random algorithm, instead of using something like a date or a time as the generator for that randomness, use 0 as the generator for that randomness. And then based on that, generate that random number, and then you use that random number in your calculation. So it's a kind of a 2-3 step process, but we are just fixing the first step in that process to be not used as a date or a time, which is generally the case is that whenever you're generating a random number, it will use a date or time as the random number generator. We are saying use 0, and that makes the results consistent. Hopefully that helps.
We haven't received any additional response, but a couple of interesting links that Perry has shared. So it's a Stack Overflow search for how to set a seed on a train test, split sklearn Python, and then another link on, sorry, I'm looking it up now, Python random state and splitting data set, how to do it and how it works.
Great, thank you guys. Yeah, just a side note. I've seen people spend time on actually setting the random state to a number which gives them better accuracy. My suggestion is do not do that. Just pick a number, whatever your lucky number is, just use that. let the algorithm be more accurate than your random state being more accurate. So pick a number, whatever you like. You like 13, pick 13. You like 7, pick 7. You like 0, pick 0. Leave it constant. Do not change that when you're running different algorithms. But try and let the algorithm do the work for you. I don't know if that makes sense, but this is just my thought on that. Yeah, I've seen people spend time on random state. It's you can certainly, but I believe that let the algorithm work for you and be more accurate. But yeah, understanding how it works is great. You should have an idea of what it is doing at the back end.
We also have some suggestions. Andy suggested popular seeds are 42 and 101.
Sure.
And Perry is saying, ultimately for this class, to match the random state to what Zia is showing, then you can set the random state, but general business and home use don't assert the random state.
Good points, both of them. All right, so if we do not have any questions, are we okay to move along?
I see one other question. Let me see.
Sure.
Pradeep is getting a clf.fit xy error. We're looking into what exact error it's giving him, but do you have any suggestions on if someone gets any errors, what to do?
Yeah, so just make sure that this name where you actually specify the classifier and what you are doing is exactly the same when you're doing the fit. Because here is where you are actually, this variable is where you are actually defining that, okay, this is the class that I want to use, the decision tree classifier. And that is the same one that you should be used to actually fit or train the algorithm. And that is the exact same that should be used to predict the algorithm. So these three should be similar, not similar, same. And they should be same. Yeah. So if they are different, then they're all case sensitive. So just make sure. And then if you still have any challenges, then I can help further.
Zia, there is, I'm not sure if we have sort of what else is on the agenda coming up, but Anna's asking if we can take a break.
Sure, we can do a couple of minutes break if people want. So I am actually going to use a different classifier. So get into that, and that should pretty much bring me to the end of it. So we can take a couple of minutes break. People can grab some water, something to drink, and then we will run through this different classifier, random forest classifier. Again, as I was saying, that decision trees are a little bit biased towards training data. Hopefully, random forest would help. So it'll probably be another 20 minutes or so, if that's okay. But let's take a 5 minutes break, and people can refresh their drinks, and we can get started then.
Okay, so everyone will come back at 1:25.
Thanks, Artie.
Thank you.
All right. Any questions that we have, Vati, for now?
We had a couple of questions. Let me take
Sure.
a look. To clarify Pradeep's earlier question, he was asking about the section farther above, I think in the modeling, I want to say, where you
Okay.
had just the CLF.fit x comma y. So farther up,
Yeah,
that
here.
section, that one, yeah. And he
So,
was getting an error.
oh,
with it.
did he have this line there? And this one. So these two lines, you need to define the CLF, which is actually decision tree classifier. And I'm sure that you have imported the decision tree classifier. So once you import the decision tree classifier and you define it to CLF, this should work. But if try this, and if it doesn't work, then let us know, Pradeep.
Okay. There is another question from Ken, and this is a suggestion. Would it be possible to go over some viable typical methods or strategies to deal with nulls at the end of the workshop?
Sure, we can talk about that a little bit and see what's a good strategy. Again, it's not a one size fits all kind of thing. So there are different techniques. Some work better, some don't work, and depending on the algorithm, you could have different solutions also that might work. So yeah, we can definitely talk at the end about that.
Great. And Bharat had a question. Can we see which data set failed to predict correctly?
So
Bharat, can you clarify, are you thinking of a specific seed that's not with a very high percentage, or are you thinking of the earlier data where it didn't predict correctly? Oh, okay. Part of this, I guess you're saying look for a specific seed that doesn't have a very high accuracy.
Oh, okay. So yeah, change the seed. Yeah, you'll have to probably try. I've seen people run loops on seeds, so change the value of seed each time and try different. We can try a different seed. But again, my suggestion would be do not spend too much time trying to get the best seed. That's not the goal. The goal is not to get the best seed. The goal is to get the best algorithm. Well, in this case, it did change a little bit here in accuracy for test from 71 to 70, but yeah. So if you change different seeds, all the seed does is it changes different rows for selection for training and different rows for testing. So it's actually just changing your data. So it's not, it doesn't do anything else. It's just what the rows are being chosen for data for selection for training and for testing. And in the classifier, it actually, again, just signifies which rows are going to be chosen for training for the decision tree.
Bharat has a follow-up question. And Bharat, I think if I'm interpreting your question correctly, you're asking about how do we know why the accuracy score of the test is lower? Like, how do we know which column is causing that?
So I think that the approach that we should take is that the difference, so the training accuracy is always going to be higher than the testing accuracy. Testing would always be low, but they should not be very significantly apart. So in this case, it's about 28 points spread. That's a bit too much for comfort. So if one of them is 85 or 90 and the other one is 85, I think that's okay. Testing is always going to be a little bit lower than that. Now, in terms of which algorithm, which column is producing that, you can take out the columns and try to figure those out by yourself, like by running them separately and seeing which is helping, which is not helping. So these are some of the experiments that you have to run at that point to see. There is something which is called feature importance that you can find out, but again, it tells you the importance of the feature. It doesn't tell you that if this is reducing the accuracy or not, or increasing the accuracy, not that, but it tells you how important is that column in that algorithm at that point. So those kind of things you can find out, but again, you might have to run some experiments by removing that column and seeing if the accuracy goes up, goes down, what happens to the accuracy. And I will do one of those a little bit later, like in about 10 minutes or so. I'll add some more data just to showcase a point. Yeah.
Okay, thank you. I think we're at a good place.
Excellent. Okay, so guys, this was decision tree. Again, decision trees are good algorithms, but the number one thing that the reason people don't use decision trees simple is because they overtrain. They are very good at training when you have data within the training data set, but out of bound when you go into testing data, they do not perform as well. So what smart people and data scientists have done is that they said that, okay, if we build one tree is biased or overlearns. How about instead of building one tree, we build 100 trees? Maybe when we build 100 trees, the learning from one will cancel, or overlearning from one will cancel the overlearning from the other, and we might have a better result. So when you have not one decision tree, but multiple decision trees, that's a forest. So that's why we have this classifier random forest. Now this comes again from the library sklearn, but not from tree, but from an ensemble. Ensemble means basically combination of many things. So it's a combination or an addition of many decision trees, and that's why it's a forest. So it's a random forest classifier. Again, the steps are exactly the same. So we import the random forest classifier class from ensemble from sklearn. We kind of assign it to a variable. So we define that we are going to use this classifier for our algorithm, and we assign it to this variable rf. You can name it whatever you want to name it, and then you train. You train your algorithm based on X train and Y train. Once the algorithm is trained, you can actually predict and check the accuracy. Very similar, exactly the same similar steps that we were doing earlier. And you see, we did random forest instead of building one trees. By random forest, by default, I believe builds, where is that? So this parameter here, n estimators, guys, this is telling us that there are, n estimator means each estimator is a tree. So there are 100 trees that we built instead of building one tree. So this parameter n estimator, you can change it from 100 to 500 to 20 to 1. If you do it 1, then it's just one tree and it's a decision tree classifier then. So this n estimator tells us how many trees we build. So in this case, we build 100 trees. And we check the accuracy. And again, the training accuracy is similar to what we had on the train for decision tree, but the accuracy on the test improved a little bit. So it went from 70 to 72%. So it did help. Building many trees did help in this case. And sometimes this could be significant because we have a smaller amount of data. Splitting it or building 100 trees is not really helping it that much. But we have, when you have larger amounts of data, like hundreds and millions of rows, it will definitely help that. So we did get a little bit of a better test accuracy, but our accuracy on the training data set is the same. However, we did build 100 decision trees. So that's one way of actually trying to get a little bit of a better result. Having said that, again, it did not help significantly. So what can be done? So what we are going to do is we are going to go back, and you guys can continue going down, but because I am very lazy, I am actually going to go back and change the data set. So where I define the X and the Y, I am actually going to add some columns here. So let's add, we did not add gender and we did not add dependents. So let's add these two columns. So I am going to add these two columns here. One was dependents, the other one was gender. And the third one, let's do co-applicant's income also. Okay, so we have added three columns, dependents, gender, and co-applicant income. So let's run this cell again. Run the data info again. So now we have dependents, gender, co-applicant's income. Nothing is missing. Everything is a numeric. So we are all set. Let's add these three columns to our X as well, which is the independent data sets. So we add those three columns to the independent data set, and we leave the Y exactly the same. So Y is still the lone status. So now we have, instead of three columns, we have doubled the amount of data. We have added more columns. Either we went back to our database team and said, can we get some more columns, or we got that data from somewhere else and added it to our data. So we are going to add some more data in our, so again, remember that iteration, that repetitive information that we used to, we added that information in our data set. And now let's go down, and where is the train test split? Okay, so now we have to do the train test split again because our data is a little bit different. Right now we have three columns here for X train and one column for Y train. So Y train would remain the same, but let's have now, instead of three, 6 columns. So we have 6 columns now because we added those 3 additional columns to it. So we did our train test split again, and we added some more data into it. By adding some more data, we are going to now retrain our algorithm. So we retrained the algorithm. So this is where the decision tree class, oh, this is the decision tree. I wanted to do it on random forest. Okay, so let's go to random forest. So random forest, we kind of reinitiate the random forest, but this time you can call it something different so that it makes it a little bit easier. So random forest, and I'm going to just call add an A to it. So it's a separate classifier. It's a different classifier. So you add a random forest A to it, and then you add another random forest A to it. You retrain, and then let's see what happens here. So you see this went up. Hopefully, so the training accuracy went up, but hopefully the testing accuracy also goes up. So it went from 72 to 76. So we got a bigger change by adding more data to it than by changing the algorithm. So the point that I just wanted to kind of highlight here is that I wanted to showcase that by adding more data, you help your algorithm be more decisive, be able to give you better results. You will see that you get better results or more improvement in your results when you add some additional data. Now, with adding some additional data, you have to be careful because sometimes you add a noise to it. So noise doesn't help. But hopefully it is good data, and when you add good data, generally you get a bigger jump in your results by adding more data to it. So I'll let you guys try that, but these are some of the approaches that you can see or you can do to actually help get better data. In this case, let me just add one more cell right underneath this, and let me show you what does XTrain have. So in this case, when we look at the XTrain data set, so when a user comes to your site, now you are asking him 6 questions. Tell me what your credit history is. Tell me what your income is. Are you married? How many dependents? Are you a male or a female? And is there a co-applicant? And if there is a co-applicant, what kind of income does the co-applicant have? So you added more information to it. And by adding that more information, you ask these extra questions, and that helps you get a little bit of a better result. So I will let you guys copy this, and then we can, maybe Artie, we can open it up for questions, and we'll try and see if people have questions on this. This kind of brings us to kind of the end of what I wanted to showcase.
So yeah, waiting for questions. I haven't seen anything new so far. Just checking on the X-train, the split. Would you mind going back to your code that you used for that? Did we use the one with the seed or without the seed?
I used the one with the seed, correct.
13. Okay, I wanted to make sure I used that.
Yeah. And I used the 13 seed for the algorithm also.
We have a couple of questions.
Sure.
So Garrick is saying the model is 73% accurate at showing if a borrower will default to yes or no. Is there a way to predict the probability of default, not just yes or no?
Good question, Derek. Yes. So the model is showing here that we are 76%, or in your case, maybe 73% accurate. And what we have is RFA.predict. So this predict actually gives you the prediction 0 or 1. Predict proba will give you the probability. So click predict proba and go xtrain. Oh no, not xtrain, xtest. And this will give you the probabilities. This is the probability of 0. This is the probability of 1. And this is one prediction. The algorithm is 98% sure that the first person is going to pay back the loan. The second person, it's 56% sure that it's not going to pay back the loan.
And Zia, there was a question if from Khalil, if you would be able to share the notebook you're working on.
I certainly can. You guys will have to give me a little bit of time. I might be able to do it tomorrow. I have a couple of things right after this today, but in the next day or two, I can share it with you guys, Artie, and then you guys can, or I can send it to individuals if they are interested. They can reach out to me. I'll share my email address at the end, or I think people have it, so they're welcome to reach out to me.
Sure. Yeah, and actually there was a request to get your slides as well. So perhaps it would be easiest if you could share the slide and the notebook with me and Andy.
Sure.
And we'll make sure to send out sort of all notes. And once we have the conference has concluded, we will be doing some minor editing of the videos to make sure it has an easier flow. And we're going to be sharing out all the videos as well of the entire conference, every single session. So
Okay,
give us some time to get all that coordinated, and we'll make sure to send every one of you an email. We got one more question.
Sure.
Can you explain why we get this warning in the random forest? It says data conversion warning, a column vector Y was passed when a 1D array was expected.
Yeah, so what it is saying basically is that, remember where we defined Y? Where did we define Y? So why we defined Y? What it is saying is that do not define Y like this, define it with 1 square bracket. So let me just do this, and hopefully that warning will go away. It's saying that I'm expecting a 1D array. So no, I need to redefine the. So these are some of the things that you have to remember. Now, because I changed the Y, I have to do the retrain test split again. So when you're rerunning it, please keep all these things in mind. And now we do this. Oh no, this is the symmetry classifier again. Redefine A and then redefine this. So you see that error goes away now. It was just saying that I'm expecting only one dimension. You were passing 2 dimensions.
Thank you. And there's one more question. Could you explain how to read the array output in the predict_proba one more time?
Sure. So you see this square bracket? From one square bracket to other square bracket, before this comma, outside of the square bracket, this is one prediction. The first one is probability proba of 0. So probability of defaulting. So probability of defaulting is 0%. Sorry, for 0 is 0.2, 0.02 or 2% or 0.02, and the probability of paying back is 98%. So the default probability is 0.02, paying back is 98%, and this goes for every row. So this is the second row. This is the third row, or third customer. This is the fourth customer. So the probability of defaulting is 2%, the probability of paying back is 98%. Or probability of 0 is 2%, probability of paying back is 98%.
Okay, thank you. I'm not seeing any other questions so far.
Are there any more questions?
Yes, guys, if you have any other questions, please feel free to ask. Again, my email is there. If you have something else afterwards, even you can reach out to RT, Andy, or me, and I'll be happy to reply back with an email if you have any questions. Again, do give me a little bit of time. I have to travel back to the US before in the next few days, so I'll reply after that.
Zia, there was the earlier question Ken had asked. Would it be possible to go over some viable methods and strategies to deal with nulls?
Oh, yeah, correct. Yes. So null is kind of a tricky situation. I know many data scientists who strictly believe that nulls should never be changed. If we don't know the answer, we don't know the value. So they do not like to put any value in there. I am a little bit different. I'm okay that that if you put some values in there, again, you have to see that you do not distort or do not add noise to your values. So sometimes it's a good idea to see if a median is a better choice than a mean. Usually people will go with either a mean or a median or a mode. A mode in terms of categorical data and median in terms of numeric data. Median being the center point is generally considered a better choice because it is not skewed based on big values or larger numbers and smaller numbers. So if you have one person whose value is very big, so he makes like $500,000 a year, and everybody else is in like $60,000, $80,000, $100,000 range, that one person can skew the mean or pull the mean towards himself a little bit. So median generally is considered a better choice. Now, that being said, again, sometimes mean is better also. So you have to kind of see with that. The other option is that you can actually write an algorithm to predict that null value and then use that predicted value to do that. So again, it depends. So there is no one way of doing it. There are many different ways. You can drop them. You can fill them with 0. You can fill them with a different value. You can use a median. You can use a mean. You can predict the value of those. It depends on what your tolerance is for any kind of wrong values. If you have large enough data set that you can drop those blanks, I think that's probably the best approach. Again, if you have large enough data set that you can drop those, you cannot train on that. But again, because again, if you're predicting or if you're putting something in this, you are actually assuming and you're putting something in there. So you might want to not do that. But again, if you have a smaller data set and you want to keep every value in there, or if the null values are too big, or too many nulls in there, then you might have to predict, and in that case, you can predict. Does that answer? Does that help?
Thank you. And I think Ken's follow-up to that is, would external data sources be an option?
To fill that value in? Absolutely. Yeah, totally. If you can get it from a different source, the same value, absolutely can.
Okay, thank you. We have another question. Once we know the probability of a customer paying back or not, how do we use the information? And Annalise is also asking, can we print the ID number of the client so we know who will pay? So 2 questions: how do we act on the information? And 2, how do we print the number of the client?
Okay, great question. So in terms of probability, so when we're looking at the probability, now the algorithm decides that if you have a more than 50% probability, you will pay back the loan. You can change that yourself. You can say the bank threshold is 80%. We will only give loans to people who pay more than 80%, who have a probability of more than 80%. So the bank is more conservative. Or the bank could be more liberal in terms of that they can say, no, we will even give loan to people who we are only 40% sure. However, we will charge more interest. So you can actually, the probability, how it helps is it allows you to make the decision. Instead of the algorithm saying that, okay, it's a 0 or a 1, you can pick, okay, my threshold is 80% or my threshold is, or I will give a different interest rate to people who have more than 80% probability of paying back, and a different for riskier loans, which is less than 50%. So you can make those tweaks. How do you add this back? Yeah, no big deal. This, if you look at this probability, this is the test data set. The test data set, you just have to merge it back because it will be 123 of those. So how do you find that out, that if it's the 123? Where are the predictions? Oh, I didn't do that. Yeah, here. So if I find the length of this, this will be exactly, the length would be exactly 123. So you see, I checked the length. So you just merge each probability back with the original data, and then you will find out exactly who paid or who did, who has a higher probability of. So a join or a merge, whatever. If you're doing it in SQL, it's a join. For pandas, it's a merge. So whatever you want to do, it's exactly 123. That will fit exactly in line with your test data set. So you merge them back with the test data set, and now you exactly know who's going to pay back versus not pay back.
Okay, thank you. Let me check the chat. Paige is asking, are all of these, the variables that we have, independent variables, are all of those allowed to be used for prediction? Like, is it legal to use gender?
Yeah, I don't think that there is anything wrong with using that. In terms of legality, like it's a data set. It's a data that you have within your system. So I think the question more is that can we bias it based on that? So I think that because we are just looking at historic data, it's just whatever happened in the past. So we are not making any assumption based on that. So again, I'm not a lawyer, so I'm not sure that if there could be any challenge on that. But I do believe that because this is just historic data, that's what's happened in the past, you're not sharing that with anybody else also. So it's not, it should be okay. But again, I'm not a lawyer, so I can't speak to that piece.
Okay, thank you. And we have a question from Angela. Did you plan to go over k-means and PCA in today's session?
No, and both those techniques, Angela, are kind of unsupervised. K-means, yeah, so they're both unsupervised learning, and yeah, no, I was not planning on going any of those, even PCA. So that was not, at least not, they are a little bit more involved techniques, so need a little bit more time to actually go over that. Yeah.
There's another question that says, how can I apply data science in ML techniques in stock trading and analysis?
Yeah, you can certainly do apply machine learning for stock trading. It is a very difficult subject because stock prices are not just dependent on 5 or 10 or 50 features. They are dependent on what's happening in the economy. They are dependent on the political condition. They are dependent on many different things. So it's a difficult field, but you can certainly apply that. And there are many different companies who use those also. So if you search on Google, you will find a lot of companies working with stock data, and you can use those as some reference examples. But it's a difficult field because it uses so much information from outside of what presently companies have to work with. Like external features can hugely impact the results. So it's a very complicated process. But can it be done? Sure, it can be done.
We have a question from Perry. Any good book or website references that you recommend?
So I think a great starting point, of course, is the course that we offer. But outside of that, I think Kaggle is a good resource. So if you guys are looking into data science, Kaggle, it's spelled as Kaggle, has some data science introductory information, and it also has some data sets that you can work with, play with. It has some kernels that you can look at and see how other people have approached it. So it's a great site from there that you can use for. So that would be probably my number one recommendation. There are tons and tons of books by great authors. So yeah, I think the content is so much that it's kind of overwhelming. But there is tons of resources that you can look at. You can look at Udemy, Udacity. There's some free online courses there also that you can look at. We partner up with Bradman University for training as well. So Bradman has a few courses as well that you can look at in terms of training to see their webinars, seminars that you can do at. And a Kaggle is a great starting point as well.
Thank you. Yeah, and just to add to what Zia said, the Kaggle has, I think, a similar concept to Google Colab, where they have notebooks. With the kernels, it actually comes preloaded with Python or R. So you can do some pretty cool things right in the environment, and you don't need to install anything, which is helpful.
Yeah.
Zia, we have a follow-up question from Angela on exact steps to merge the data between the X-train and the predict, but perhaps we can take that as an offline question. And
Sure.
we
Yeah.
can send back links and such as part of the notes.
Sure.
Any other questions?
Hey, Zia, did you want to make a small plug on what your training offers versus everyone else, especially during this COVID time?
Sure. So I think I'll just say this, that what we do is what I just did today. So we actually take piece by piece, and we actually work through through training all day long. Now we used to run it in person. There is no in person anymore because of this pandemic, but we run them virtually now. But exactly how I did this. So this is kind of you can think of it as an intro to it. So this is how we run the whole class. People ask questions. Our classes are very small, like maybe 10 people maximum, usually 6 or 7 people, and we do a lot of projects. Every day is a project, so that it makes it easier for people to actually do by practice or by doing it. Coding and data science, all of these are just like swimming. So you have to do it to learn. It's very hard to learn from videos, because videos will give you great information, but if you don't do it, you cannot. So you have to get in the water to learn swimming. You have to code to learn coding and to do data science. So you have to do projects, and that's what we focus on. The course that we run runs for about 4 months, so it's pretty intensive.
There's a question in the chat. Can you post the link to your training site?
Sure. Can I post something on the chat here?
I see the chat function is entirely via Hoover. So
Okay.
If you want to send me and Andy the link, we can definitely post it up here.
Sure. And Arti, if you don't mind, maybe it's just like the www.theDevMasters.com.
Okay, I will post it.
Thank you so much.
Are there any other questions?
And thank you everybody for bearing with me for a terrible internet connection that I had, but hopefully we were able to get through it.
Okay, thank you, Zia, for this data science tutorial. And I appreciate all the attendees for the questions and interactions, and of course, patience in the beginning, but I think we all bear through it. And I think it was a great session. You'll contact Zia if you have any questions. You can email him. Please provide your comment and feedback to us or the organizers on the community board, or start a discussion to connect with others in the DataCon LA 2020 community. Thank you for joining today's tutorial, and I hope you gained some insights from this session. Have a wonderful day, and thank you for being a part of this year's DataCon LA 2020. Thank you, Zia. It was a great tutorial. I learned something. Thank you, Artie, for handling all the Q&A. We will see you next year.
Thank you so much, everybody. I appreciate your time. Hopefully it was useful.
Thanks, everyone. Bye.
Bye.
Bye. Thank you, Andy and Artie. Thank you for your help. You guys were great.
Of course.
Okay, bye.
Bye.
Bye.